Hello, my first PUC warriors. So, welcome to the class. Today, I'm going to discuss your entire FA-1 portions in this video. It might be a little long session, but if you watch till the end, if you watch and solve all the questions that I brought for all of you, certainly you will be saying to yourself, "Thank you, sir," and of course, you'll have much better preparation. Okay. So, not only questions. I understand some of the times we forget the formula, some of the time we forget some concepts, so I'll revise those concepts as well. Okay, so two things you have to do: watch this session till the end, and you have to get this PDF of this class, because in that you'll find all the concept revised at one place. All the related formulas, concepts, graphs will be placed over here. Okay, so I hope this is clear. Now if you are here to watch me for the first time, do not forget to join us by subscribing to our channel Diksha Karnataka, and to get more information regarding any of the information, join our WhatsApp channel. You will find all the links in the video description over here. Click on the description and check from there, you'll get all the links. Okay, so today I think clear what we're going to do. Let's get relaxed first of all. Today we are here to give some time, sir. You and me will spend some time together in this class. When we do that, we'll end up with much satisfied preparation. That is a surety, a guarantee from my side. If you watch till the end, I can guarantee you you'll have a preparation which you will be proud of. Okay, so I'm going to cover what topics in this chapter. In this session, I'll cover up your sets, relations, functions. I'll cover up your trigonometric functions as well as complex numbers. So first 4 chapters will be covered up. Okay, I'll repeat again: sets, relation and function, then you'll have trigonometric functions and complex numbers. These 4 chapters I'll cover up. Let's start the session right now. Okay, so what else? So first thing is, what we have planned for all of you, right? So if you are, let's say, a second PUC student watching this by mistake, this is what your PUC calendar, second PUC calendar FA1 preparation marathon looks like. And this is for your first PUC student. So for first PUC student, you'll get this session for maths. You have a bio and physics session also scheduled for all of you. Okay, this is your calendar for FA1 marathons from our side. Now for the chapter, let's start sets. What do we have? What I have planned for all of you? So I have planned 10 MCQs as well as 15 questions of 2 and 3 marker. These are very much, very important questions. What about MCQs, sir? So beta, MCQs are difficult to predict, right? But if I show you these 10 questions, now you can understand, yeah, like this concepts, based upon these concepts, similar question can come. Okay, so that's why these are important 25 questions from the chapter set theory. Clear or not? Very clear, sir. Okay, moving on. Now this is very, very important. This is regarding your notes and all the help. So what we have done this time, have created something very amazing for all of you. Please listen to me. Do not move on right now. Listen to me very carefully. This is something for AIO. What is AIO, sir? It means all in one page. Okay, so what happens in AIO? So this class notes you need, right? That notes will be provided in this AIO. What is this AIO? So if you check any of our videos, okay, in that you'll find a link which will say join the free second PUC or course, like that. So if you click on that link, you will be, you'll be directed towards a web page. I'll show you, and over there you'll find your lectures, everything scheduled, and over there you're going to find not only the lectures, alongside you're going to find the PDFs also. So basically it is a classroom experience, a next level of personalization given for free. This is not of any charge. Okay, this is the learning platform, online learning platform, which is of no charge for students who are serious about studies. Okay, of course you can study on YouTube also, but there are many distractions. Okay, there are many problems on the YouTube side, but to make it more feel it more like classroom, we have developed this platform for all of you. Okay, so how does it work? So let me show you a sample demo. You have to, of course, as I mentioned, check any of our videos. Over there you'll find this written as join free AS KCET 2027 course. So free course. Okay, click on that free course, click on that. You will be directed to this website over here. If you come to this web page, you'll find over here AS KCET 2027, and you'll have to click on buy now. When you click on buy now, don't worry, it's of no charge, it is completely free. If you click on buy now, you'll have to create your login credentials. You have to create your login information. For that you need a number, and you have to create either OTP or password, your choice. Okay, after that, once you've created that, You can sign into this web page, and from that your learning starts. Okay, you'll have schedule, you'll have your lectures as aligned there. Simply in the platform start learning right away. All the PDFs also you'll get alongside the same. So the lecture is there, same video you'll find the PDFs also attached. I hope this is clear. This is the platform, how it looks like. Now, so this is the information regarding AIO page. Now let's move to our questions, our learning. This is clear. So this is how the platform looks like. You have to log in and start using it right away. Okay, sir. Starting the chapter now. Types of sets, some basic concept. Let me revise it quickly. So empty and null set, what is that? A set which has no element is called as empty set or null set. Okay. Singleton set which has only one element, so singleton set. Finite set are those set which has fixed number of elements. Acha guys, I have given you a proper words that you should write in the exam if it comes. Okay, I'm explaining you in the easier way, but try to write the text given over here. Infinite set are the sets which are having infinite means number of element which is not fixed, or unlimited or uncountable number of elements. Equal sets means which has same number of element and same element, means which has both exactly same elements and also number of elements are also same. Okay. Equivalent set where the number of element is same but not the same element. Okay. So in this case the cardinal number is same, that's why same cardinality, but not necessarily the same elements. That is called as equivalent sets. Next is what? Universal set, a superset containing all the set under consideration. If I'm talking about, let's say, set A, which is 1, 2, set B, let's say 3, 4. Okay, then maybe let's say 2, 3, 4. Then universal set will be which is superset to all of this. So 1, 2, 3, 4. So all the elements will be part of. So A will be a subset of U and B will be subset of. Superset containing all the sets under consideration is called as universal set. Now what is superset and subset? Over here, subsets and power set. So A is subset of B has this symbol, A subset of B. What it means every set means every element of A is present in B. What it means? Every element in A of A is present in the set B. Okay. Every set is a subset of itself. If I say A is a subset of itself, correct. Every set is a subset of itself. Okay. And null set is a subset of all the sets. So null set is subset of any set or every set. Clear, right? If you have this symbol, this means subset. But if you have only this symbol, it means proper subset. There's a difference, okay? Proper subset. Proper subset means what? It is subset but not equal. Means if A is subset of B, but A cannot be equal to B. Example, don't worry, I have taken a question like that as well, but let me show you over here. If let's say I have a set B, okay, set B is 1, 2, element 1, 2. I can write subset of this set. Yes, sir, you can write. So subset, if I'm writing, these are subsets. So I'll have 1, I'll have 2, I'll have 1, 2, okay, and I'll have nothing also, so null set also. These are the total subset of the set given 1, 2, okay. But if it's supposed to be a proper subset, then I have to remove this part. I have to remove this part over here because it says that cannot be equal to the original set B. So proper subset means the same set cannot be present over there. Everything else, so this is also proper subset, means this set are proper subset but not subset, okay. This cannot be there. That's why A cannot be equal to B. Moving on. Number of subsets, this is also called as power of a set. This and this formula is same. Can you check? Number of subset and power of a set. A power set is same thing, okay. Number of non-empty set. What is the meaning of that? When you write number of set, you also include null set over there. Can you see? In this number of set, what is the number of element? If I ask you, sir, we have 2 elements, so 2. Apply the formula. 2 power n. The number of subset will be what? 2 power n. So 2 power 2. How much is that? 4. Please count here. 1, 2, 3, 4. 1, 2, 3, 4. Good, sir. But when you write number of non-empty subsets, you'll have to write what? 2 power 2 minus 1, because this represents empty subset. This is a empty subset. So you have to remove that part out. That's why 2 power n minus 1, because each of the set will have one of the set as null set, one of the subset as null set. That's why it is minus 1. Number of this is same as proper subset, because in the case of non-empty set you're going to remove the null set. In the case of proper subset you're going to remove the same or equal set. Okay, great. And number of non-empty proper subset you're going to remove both. You're going to remove both. That's why it is minus 2. You're going to remove this and this both. So they are the formulas. Please remember this. Now let's look at the concept of interval. Open interval, both brackets are open. There is no equal to sign over here. Closed interval, both brackets are closed. And there is no equal to sign over here. Both brackets are closed. There is an equal to sign. You can see this is a less than equal to, less than equal to. This is what? Less than and less than. This is called as open and closed interval. Now we have combination, semi-open, semi-closed. So when you have square bracket, that is closed. The small bracket, that is open. You can see here A is closed, B is open. Here we have double, less than equal to, this is less than. A is open, B is closed, less than and less than equal to. But I hope you remember that. I'm just revising this. Now properties for set on intersection. Okay. So A intersection B means what? That element that X belongs to A will also belongs to element X belongs to set A and B both. A intersection finite is null set is what? Null set. What is common between A and a null set? Nothing is common, right? That's why it is. Yeah, basically a null set will be there in set A also. That's why it is common. A intersection A is A. This is called as idempotent law. A intersection with union is A, and A intersection with B is same as B intersection with A. Commutative law. A intersection B intersection C is same as. You can write this anyway. Either take AB first and then take C, or take BC first and then take A. Same thing. This is associative law. Last one is, if A is subset of B, then intersection of A and B will be what? A only. If A is a proper subset means A and B are not equal, then intersection will be simply equal to A, because A is smaller, right? A is smaller, and every element in A is present in B. Correct, na? If A is a subset of B means every element in A is present in B, but not equal to B. It means intersection will be what? Simply all the set A. Operations on set. Union. Same way. This is the property for all X. This means X can belong to either A or either B. That was and. Check here. Has to belong to both. In this case, either of A or B. A union with null set is A. A union with null set is always A. Okay. A union with A is again A. This is idempotent law back. A union with universe is U. Okay. Properties again continues. Commutative, associative, and the proper set wala property. Okay. Because in this case B is larger, right? So union will become the larger set. If you want, you can write simple example of 1, 2, 3 and check and verify all of them. Okay. But if you know it already, please revise and remember them. Moving on. Distributive laws. Distributing union over intersection. Right? Union with B, intersection, union with here. Intersection over union. So intersection with B, union, intersection with C. You check? Simple. Intersection with B and intersection with C taken with union. Difference of set means present in A minus absent in B. C means present, A means absent. Present in A and absent in B. What it means? Let me write that for you. Means present in A and absent in B. Means A minus B. So I wrote here. That's why I wrote that PA minus AB. Okay. X belongs to A but not belongs to B. A minus B is not same as B minus A generally. not always same. It can be same in question to question, but not generally same. A minus null set. If you remove nothing from A itself. If you remove everything from A, it becomes nothing. So null set. Symmetric difference is the concept present in either of them, either A or B, but not in both. Not in both. Okay, present in either of them, but not in both. Okay, that's the concept of symmetric difference. Over here, complement again. It means A dash means what? Everything but not A. That's the meaning of complement. A complement means everything in the universal set except for A, because every set will have its universal set, right? So in that universal set, everything except for A will be A dash or A complement. See here, universal set minus A is called as A dash. Said no? From universal, remove the A. So everything but A. Okay. Law of double complement. A complement will be back to A. A union A dash is back to union. A intersection with A dash. Intersection of A and not A is what? Null set. U dash is null set. What is the complement of universal set? Everything but universe. That's null set. And everything but null set is universe. Okay. The Morgan's law. This distribution of what? Complement over union and intersection. Okay. So A union B is dash is given as A dash intersection B dash. Same goes for intersection also, A dash union B dash. Some formulas are there. Please repeat. Please revise them. Okay. Now cardinality means number of elements per set. That formula. N of A union B is given as NA plus NB minus N of A intersection B. We have learned this formula, right? For union, same formula goes for cardinal number also. Okay. This is for the difference. Remember, this is for difference. A minus B and B minus A. Okay. Rarely used, but please remember if it's possible. So this is like rarely used. Okay. Little rare. Okay. This also is rare only. This one, this is used, very commonly used. This is important. So guys, if you are watching this video and watching me for the first time, please refer this session, this particular video for all of the students who are writing boards. Okay, because if they are writing and they are able to find the session like this, it'll be helping them a lot in their preparation for FA-1. So please share this video with all of your friends. Very, very important. Okay, because this is board examination. It's not like they're gonna take away your college from or your rank. It's not competition. Okay, please share this session with your friends as well. Okay. Let's try to be, good human beings, good people. All right. So this is the concept side. Let's move on to the questions. I hope you understood the last one, right? Which is important. When A is a proper subset of B, the union of A and B will be what? Same as number of element in B. Correct, now? Because B is bigger. If you take union, it will come back same as B. If you take union, it will come back same as B. That's why number of element in the union will be same as number of element in the set B. Clear, sir? Time to solve some questions. Okay, let's move on. The set X, where X is the prime number, which is divisor of 60, means I want to find that number which is divisor of 60, also prime. This is also not possible because we have lot of composite numbers. This has 1, so not possible, sir. 1 will not be prime. What about this, sir? T and B. 5 is also a divisor, it's a prime also. So answer is clearly 2, 3 and 5. Because 2 will divide 60, it's prime. 3 will divide 2 times of 30. 3 times of 20, right? Yeah. And 5 times of 3. All these are divisor and they are also prime. These are all prime. My answer is what? Option C. Answer is what? Option. Even though it's a recorded session, but please try to tell me in the comment whether how many questions you got it correct, got them correct. Okay. Which of the following set are not disjoint sets? Means they are. What is the meaning of disjoint sets? Disjoint set means A intersection B is what? Null set. You're saying not disjoint means something must be common. Something must be common. Check over here. 1, 2, 3, and x in the second set we have x more than 4 and less than 6. It will become 4, 5, 6. As per this element, what is the element? 4, 5, 6. Natural number more than 4 and less than 6. Anything common, sir? What is common between them? Nothing is common, sir. I'm looking for not disjoint. I'm not looking for disjoint sets. I'm looking for not disjoint. So option A is disjoint. So we can't take that option. Here, what is common, sir? A, E, I, O, U, C, D, G, F. What is intersection, sir? Also null set. Again, intersection is null set. X is even integer and X is odd integer. What is the intersection again? Null set, sir. In the option A, B, C, it is all null set. Let's try the last one. Positive prime number less than 10. What is the element over here? We have 2, 3, 5, 7. Is there positive prime number less than 10? Because 8, 9, 10 is not there. What about this positive even integer? Positive even integer less than 10. So we have 2, 4, 6, 8. Check the intersection. You'll have the answer as 2. And 2 is what? Not equal to null set. This is not equal to null set. Means my answer is option. This was the concept, by the way. Clear? Moving on. This is question number 2. Third one. Okay. The number of non-empty subsets of the set, non-empty subsets, right? So we'll have to go what? 2 power n minus 1, that's the formula. Non-empty. What about non-empty and a proper subset? Then we'll do minus 2 over here. But this is just non-empty. 2 power n, count the number 1, 2, 3, 4. So 2 power 4 minus 1. 2 power 4 is what? 16 minus 1. How much is that? 15. You have to remember the formulas, by the way. Answer is option B. Next, question number 4. If R is the set of real numbers and Q is set of rational numbers, so all real minus rational will be what? All irrational numbers. From real number, if you remove all the rationals, the remaining is irrational. So this is not a problem. Simple question, sir. Question number 6 now. Excuse me. 5, right? Number 5. If A is the proper subset of B, the number of elements, see this question has come. So this question is taken from question bank, by the way. Okay. If A is a proper subset of B, the number of element in the union of AB will be what? I just taught you right now. Last property, NB. If A is proper subset of B means A is smaller than B. If you take union, directly the B will come. So clearly, what is my answer? NB. Answer is option. So if you know the property, direct answer will come, and they're all important. So that's why I said download the class notes from where? From your AIO, all in one page. Okay. Great. Question number 6 now. You will also feel the questions easier if you know the formulas. If you don't know, very difficult. You can't solve only, right? Okay. Any other concerns you have, put that in the comment section. I would like to know your comments. Union is given 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A is given. I'm looking to find the complement of set A. Complement of set A, we wrote a formula. Union minus the set A. Everything in union except for A. 1 we can't write, 2 will write. 3 we can't write, 4 will write. 5 we can't write, 6 will write. 7 we can't write, 8 will write. 9 we can't write, 10 will write. Okay. This is the A complement. Check 2, 4, 6, 8, 10. 2, 4, 6, 8, 10 is option B. Option B. Question number 7 now. Which of the following statement is incorrect? We're looking for very important. Incorrect statement. Every set is a subset of itself. Correct. This is right, sir. Null set is a subset of all sets. Also right, sir. Explained in the beginning only. if B is a subset of A and B is not equal to A, correct? That's what it means. This is the proper subset. Then B is called as proper, correct? This is definition of proper subset. B is proper subset. It means that B is not equal to A, then B is called as proper subset. If the set A contains n element, okay, this is wrong, na? Number of proper subset is given by what? 2 power n minus 1 actually. 2 power n minus 1. This is a wrong statement. The wrong statement. So answer is what? Option C. 7th one answer is option C. 8th one. Question number 8. Which is the following set? Okay, which of the following set are not equal sets? Okay. This is equal, no? A, B, C, D, sequence does not matter. This is equal only. 1, 2, 3, 4, again sequence does not matter, equal only. 2, 4, 6, 8, 10. Positive integer from, what is the meaning of this? Positive integer, check this out. 2, 4, 6, 8 and 10. The same thing. It's also correct. X is a positive prime number less than 10. Prime number less than 10. So 2, 3, 5, 7. This is wrong, right? Because 1 is not prime. 1 is not prime. Sorry. That is not, okay, that's not the case. They're not saying prime only. This, can you see 1 is not here? You don't have 2, 3, 5, 7 is there, but 1 is not there, means this is not equal. They are not equal. These two are not equal. My answer is option. 8th answer is option D. 9th one. Clear, right? Because in the prime numbers 1 will not come, but over here we have 1, so they are not equal, right? This is 8th, this is 9th. The number of subsets of a set A, what is that? Which is null set. Null set is this, right? Nothing is there. So how do you find number of subsets? Number of subset is what? 2 power n. What is n over here? N is nothing, na? So 0. Number of element is what? Nothing, so 0. Right here, 2 power 0. How much is that? 1. Answer is option A. Answer is option A. So number of subset of null set also is 1. Okay, which is basically null set itself. Question number 9 is done. Now, if x is a, b, c, d, y is f, b, d, z, what is x minus y? What did it say for x minus y? Present in x and absent in y. So a is there, a is here absent. And b is there, b is present, c is there, c is absent. So c, d is present. So what is my answer? A, c. Answer is option C. Answer is option C. Clear? This was your MCQs. Okay. Let's move on to suggestive questions, 2 and 3 markers. Okay. 2 and 3 markers. Write down all the set for all the subset of 1, 2, 3. Let's do that. Let's say this is my set A, which is 1, 2 and 3. I want to write down all the subsets. All the subsets. We'll start with what? First, as it is, will come 1, 2, 3. Next, we'll have 1, 2. Excuse me. 1, 3. Then you'll have what? 2, 3. Okay. Then you'll have 1. Then you'll have 2. Then you'll have 3. Then you'll have null set. Okay, nothing. Okay. Correct now? 1, 2, 3, 4, 5, 6, 7, 8. Correct. Anyone is thinking 2, 1? No. 1, 2 and 2, 1 is same. This order is changed. Element will not be changed, right? So check here. If you want to verify, formula is what? 2 power n. How many elements are there? 3. So it will become 8. Count here. 1, 2, 3, 4, 5, 6, 7, 8. This is the subset. Clear? All of them are clear? That's your subset. Moving on. Clear, right? Want to see once more time? One more time. Okay. 12th one. A is given, B is given. I have to find out A intersection B union C. A lot of questions comes from this chapter from the operation side. Okay. So A intersection with B union C. Let's find B union C first. Find this B union C first. We'll take all the elements without repetition. So 7 will come, 9 will come, 11 will come. We have 11, 13 also we have. So 13 will come, and we have 15. You cannot take 13 two times. Okay, we cannot repeat. Now we want to take intersection of this. Intersection B union C. Check here. We have 7 common. 7 is common. 9 and 11 is common, right? 7, 9 and this is my answer. This is my answer. Question number 13 now. Okay. Similar question, but we are looking for x minus y and x intersection y both. Let's try x minus y first. So a lot of questions will be there in the operation. So remember the formulas that I gave you in the beginning. Download the notes from AIO all in one page and start solving and start practicing. Okay, it'll be enough. X minus y. So present in x, absent in y. Present in x and absent in y. So A is that element, B is there, C is that element, D is there. So AC is the answer. What about x intersection y? What is common between them? Just opposite. So B and D is common. Anything else? B and D is common. B and D is common. So basically you can say that union minus the intersection. No, not intersection, sorry. No. Moving on. Question number 14. Because you have G and D also there, right? E and F also, right? A union B and A intersection B implies A equal to B. How do you solve this question? Very simple. Check. So if I take an element from A, if I take an element from A, if I take an element which is from set A, okay? This is case 1, by the way. If I take an element from set A, that element will also be present in what? Union of A and B. If you take union of A and set B, if I take an element from any one element from set A and you take union of A and B, that set will be still in the union. Yes. And they are saying union is same as intersection, which means what? X is also present in intersection. Correct. I'll repeat. I have taken any element from a set A. There is a set A. From that, I have taken an element. So if you take union of A and B, that element X will be still present over there. Correct. Now, since union of A and B and intersection are same, it means what? X will be present in intersection also. So X is present in A. This means what? X is present in B as well. Correct, na? If X is present in A and X is present in intersection of A and B, intersection means what? Common between both of them. It means X is present in A and it is also present in B. It means what? A is a subset of B. A is a subset of B. Correct, right? If X is present in A and present in B also, means for all elements present in A, all of the element of A are present in B. It means A is subset of B. Same. Case 2 now. Just opposite will do. Take an element X from the set B. You will have same element present in what? B union A. You will have same element present in what? B intersection A. It means you will have same element present in what? Set A. Just opposite. Here we did from A and got to B. Here we did from B and got to A. It means over here if you combine these two, all element of set B are present in set A. All element of set B are present in set A. It means C is a subset of set A. If A is subset of B and B is also subset of A, what it means? Combine these two. What it means? Means all the element of A are present in B and all the element of B are present in A. It means what? It means A and B must be equal, right? Because everything that is there in A is present in B. Everything there in B is present in A. So they must be equal. We proved that. Got it? Please try once and starting from X and any element from set A. If you want, you can take example and also try. Try with an example. Okay, next, let u be, I think this is the last question, right? This is the last question from this chapter. Yeah, 15 questions I've taken over here. You can see I've followed all the structure of the questions. So in the 2 and 3 markers, you'll find what important problems of operations of set. So more than the questions, of course, questions are very important, but more than the questions, the formulas and inputs I gave in theory over here, these are very, very important. Given you summary of everything at one place. So please try to utilize that properly. Okay, let's move on now. U is given, A is given, B is given. They are asking us to verify that this is equal. Let's try with LHS first. A intersection B will find first. Let's find that. Common between A and B, 2 is common, sir. That's it. Only 2 is common, 4, 6, 8 is not there. Answer is only 2 is there. Only 2 is there. 2, 4, 6, 8, 2, 3, 5, 7. So only 2 is there. Then we'll find what? A intersection B transpose or complement. It means everything in universe except for that. In universe except for intersection of A and B. We'll have this value as 1, 3, 4, 5, 6, 7, 8 and 9. So all the elements except for 2. 1, 2, 3, 4, 5, 6, 7, 8, 9 is there. I've removed 2. Except for that, everything else is there. Okay, sir. Now the second part, which is RHS side, they're asking us to find what? A dash union B dash. Let's find A dash first. So A dash means union minus A, universal set minus A. So take this, remove 2, 4, 6, 8. We'll have over here 1, 3, 5, 7, 9. 2, 4, 6, 8 we have removed. 2, 4, 6, 8 we have removed. 2, 4, so 1, 3, 5, 7, 9. Okay, let's find B dash also. Universal set minus B. Over here we're going to remove 2, 3, 5, 7. 2, 3, so we'll have 1, 4, 6, 8, 9. 1, 4, 6, 8, 9. 1, 4, correct now? Removing this, yeah, you'll have 1, 4, 1, 4, 6, 8, 9. Now they're saying universe, take union of both of this. Union of both of these. Let's find the union of both of these. You'll get what? 1, next is 3, next is 4, then we have 5 also, then we have 6 as well. So we have 7, yes, we have 7, we have 8, and we have 9. Yeah. Check. 1, only 2 is missing, 3, 4, 5, 6, 7, 8, 9. This is also same. What can you say that? LHS is coming equal to RHS. We have proved it. We have proved it correct. Moving on with relations and functions. Relations and functions. Okay, let's start. What do we have in this session, sir? Again, total I have brought to all of you 18 questions, 10 MCQs. Then we have first 6 questions of 2, 3 marker and 2 questions of 5 marker from relation and function. This is the chapter outline. I hope you found the first part of sets to be helpful and informative for your preparation. Let's move on. So these are the these are the questions that will help you prepare much better for your for your FA-1. Okay, so now if you know anybody who is preparing for second PUC, of course your seniors, okay, then refer this Pariksha Veera batch to them. Okay, ask them to check it out. You'll find the link for this in the video's description. Ask them to check it out, and this is something that therefore second PUC student, ask your seniors, refer your seniors if they want to study with us, with Diksha Vedantu, with our platform. Just check out Pariksha Veera batch. It's a full year batch. You'll find link and detail all of that in the description. Just share the link with them, nothing else. Okay, that's all. Let's move on now. Ordered pairs, and so as I mentioned, let's do some concepts first, then I'll move on to the question solving. Clear? Okay, sir. Ordered pairs and Cartesian products. Ordered pairs and Cartesian product. What is there? Ordered pair, if it is given A comma B and C comma D, it means A and C are equal and B and D are equal. That's the meaning of comparison of equal ordered pair. Okay. Over here not equal, because only if A and B are equal, then we can say AB equal to BA. This is the ordered pair. What's the meaning of Cartesian product, sir? This is very simple. You have to start, for all the elements of A, you have to, make a ordered pair with elements of B, like this. Okay. So A comma B, for all A belongs to set A and B belongs to the set B, right? This is the representation of number of element in the ordered pair in the Cartesian product. So if the number of element I'm looking for in the Cartesian product of A and B is same as NA into NB, same as NA into NB. Generally, A cross B and B cross A is not same. Means Cartesian product of A and B is not same as B and A. If A is a null set and B is a null set, then A cross B will also be a null set. And number of subset over here becomes what? 2 power mn. Can you justify this? Please check. If the value of NA equals to m, the value of number of element in the set B equals to n, then A cross B will have how many elements? Please check. It will be product of these two from here. So m into n, m into n. For this set A cross B also is a set only. For this set, if you write number of subset, you write like this: 2 power number of elements, so 2 power mn. That's what is there over here, 2 power. Some laws: A cross B union C is same as A cross with B union A cross with C. Same goes in the case of intersection, same goes in the case of difference, and same goes in the case of intersection of two Cartesian product. Intersection of two Cartesian product. We'll use that in the question solving. You need to remember it. Relation, some definitions is there. What is definition of relation? So of course, if you're writing the Cartesian product, any subset, relation is a subset of the Cartesian product A cross B. So if you're defining a relation R from A to B, what it means is, if you write A cross B, if you write set of all the ordered pairs, set of all the ordered pairs of A cross B, the relation means to be a subset. Any subset from this relation A to B will be called as, that subset will be called as relation. That's why R is a subset of A cross B. R is a subset of A cross B. Okay. So either you write A belongs to R, you write it as A R B, they are the same thing. Either you write in the form of ordered pair A comma B or A R B. What it means is A R B. So you write this as A comma B, the same thing. Means A related to B. What is domain? If you're writing the ordered pair, the first element, set of all the first element. If let's say I have 5 ordered or 2 ordered pair, 2 comma 1, 5 comma 7, then this 2 comma 5 is called as domain. Set of all the ordered pairs, first element of the ordered pair is called as domain. Same way, set of all the second ordered pair is called as range. And range is always less than codomain, and codomain will be given in the question. It is always given in the problem. Okay, don't worry about that. Codomain is your set B. What is codomain? That is my set B. So range is always less than, or basically subset of codomain. Counting the relations, so if NA equal to M, NB equal to N, I did that already. Total relation will be 2 power Mn. Non-empty relation 2 power Mn minus 1. And total relation from A to A. What happens to A to A? So N of A will be also, let's say, M. N of A again will be what? Same thing, no? M only. 2 power M into N will become 2 power M into M. So becomes 2 power M square. I hope this is clear. Please download the notes and access all the formulas. Have a look one more time, just for reference. Special types of relations: empty relation, which has no element; universal, which has every element from the Cartesian product. Okay, every element related to every single element. Identity, just to itself, A to A is identity. Okay, inverse, very simple. R inverse is, if you are writing AB over here now, for every AB you will have a inverse relation as BA, just ulta. Okay, what happens in inverse? Domain and range interchanges. Domain of inverse is same as range of the relation R. So this is R inverse relation. Domain of inverse relation will be equal to range of the original relation R, and range of inverse relation will be equal to domain of the original relation R. This will help you understand in the case of functions. In the case of functions. What is function? So function is a relation which follows two rules. What is the rule? Every element of A must be mapped. Okay, basically everyone has one image, unique image, and every element is mapped. Okay, and no element has two images. Means I cannot have this. Let's say this is my set A now, this is domain set, and this is codomain set. I cannot map it to two different elements. I cannot have the image of same element to two different images. Okay? No element can have two image. This is not a function. This is not a function. It's not fx. Okay, 1 second. Not a function. Clear? What is a function? It's a relation which has every element in the domain is mapped, is related, is mapped, and none of the element will have two images. Okay? Domain, what is domain, sir? Same thing. The input set A is called as domain. What is codomain, sir? The output set is called as codomain. What is range, sir? All the set of images in the mapping, whatever are the images or the second element of the ordered pair, called as range. And always range is either less than or equal to codomain. Range is always a subset of codomain, so less than or equal to. It will never be more than that. Range is never more than codomain. Clear? Okay, sir. Counting and equality. If Na is equals to m, nb equals to n, the total number of functions from A to B is given by n power m. Different, okay? N comes from nb. So basically the formula is what? nb power na. Okay? Number of elements in the set B or the codomain set to the power na. This is the formula for number of functions. Okay? If f and g are same, they must be having same domain and same codomain, and they also have fx and gx equal for all the x values. Okay? Every function is a relation, but not every relation is a function. For a relation to be a function, for a relation to be called function, these two conditions must be true. But every function is a relation, but every relation is not a function. Condition must be true. Vertical line test you can do for any function. If you want to identify whether it is a function or not, draw the graph and do a vertical line test. Draw a line. If you get one intersection, it is maximum one intersection. If you get, it is a function. It is a function. Okay. Standard functions, some examples are there, and on this definitions, there are 5 mark questions. I have taken some. I'll show you as well. There are 5 mark questions that comes from here. Okay. Identity function means the input gives back the same value. So f of 1 when it is equal to 1, f of 2 is equal to 2, and so on. So when f of x is equals to x is called as identity function. Domain is always all real, range is always all real. You have to remember that. Okay. Line is always going through origin at an angle of 45 degrees. This is always 1, 1 and on 2. That you learn in, you'll learn in second PUC, don't worry. This is from second PUC. So ignore this right now. This you can ignore right now. Constant function means for any value, always constant, means f of 1 is also, let's say 5, f of 2 is also, let's say 5, f of 15 is also, let's say 5, and f of minus 15 is also, let's say 5. What it means? It means function for any value of x is what? Equal to 5. It's called as a fixed or constant function. Domain is all real numbers, but range is only that constant c. Graph is what? Always horizontal to the x-axis. At this point, what is it? Let's say c. Y equal to c. This again, ignore it. This is for second PUC, many 1 and into. Ignore this. Modulus function, very important. This is very, very crucial. Modulus function is a function which has positive value for all x positive and negative for all x value negative. Okay. So basically, modulus function is a function which will give me the graph like this. For all positive x over here, for all negative x also positive only. How do we get that actually? Remember this line. Which line is this? this function. This is called as identity function. This is the identity function. If you take modulus on that, this part you see over here moves upward, and this is removed. So if you apply modulus, okay, on the identity function, it becomes, so identity function becomes modulus if you're taking only positive value into the consideration. Okay, all right. Set of some other functions: signum, polynomial, rational. Let's look at this. Signum function is a function for all x more than 0, it is 1. How the graph looks like: open 1, open -1. This is, for 0 it is 0, for positive value it is 1, negative value it is -1. This is the graph of signum function. Domain is all real number, but range is only 3 values: -1, 0 and, okay. Polynomial and rational function. Polynomial function is what? Again, you're gonna write it like this. It can be having any degree, okay, degree 1, degree 2, or constant function, whatever it is. Domain is always real number. In polynomial, we usually refer linear, which is a straight line. We have quadratic, which is a parabola. We have cubic. Three curves are there. Linear will be straight line. This is parabola. Quadratic, it can be positive or negative also. Cubic is always this curve. This is cubic. Okay, now what is the rational function? This is different. Okay, this is polynomial, this is rational function. What is rational function, sir? It is always in the form of like this: px upon qx. Does that qx is not equal to 0. This is our rational function. So in this, just remove that value of x which is going to be making it 0. You check here, from domain all real number except for that value of x which is making it 0. That is your rational function. This greatest integer function, also called as step function or staircase function. How does the graph look like? Closed, open, closed, open, closed, open, open, closed, closed, and so on. Values are -1, -2, 0, -1, -2. This is 1, 2, 1, 2, 3, and it will keep moving on. Okay, always. Does it look like step? Check step function. Okay. What is domain over here, guys? Domain is all real number. You can take any value, and range is what? Only integers. You get only integer value as the range: -2, -1, -0, 1, 2, like that. Okay. Great. This is the representation. Fx equals to, in the square brackets, x you will write. This is fractional part function. Means from the original function x, remove the integer. Example, from 1.2 I remove what? 1. What is the answer, sir? Was just 0.2. Okay, this is what it works like. 1.2 minus 1 is what? Always 0.2, and this is called as your fractional part function. It's always, domain is all real number, range is between 0 and 1. Range is always between 0 and 1 because it is fractional part, right? It will be always decimal between 0 and 1. Okay. And for any integral value, fractional part is what? 0. If I ask you what is the value of this, is 0. Okay, moving on. Let's look at the questions. So guys, please download the notes. Very, very helpful to all of you. Download the notes. Now, if P12, then the number of, when set is P12, the number of element in P cross P cross P. P cross P cross P. What did I say? 2 power you'll have. So what? N into n over here. You can take 2 at a time also, but it will be same thing. 2 power, what is this? 2 into 2, because np is equals to n equals to 2. So 2 power 8. Sorry. Excuse me. Number of elements they're asking, right? Sorry. They're not asking number of. Sorry, guys. They're not asking number of. My bad. I thought they're asking number of relations. Sorry, they're asking number of elements, na? My bad. Then this will be what? Simply np into np into np. What is this? This is n of P cross P cross P. This is the number of elements, not the number of relations. We'll have answer as 2 into 2 into, that's how much? 8. Option is, question number 1, option is question number 2 now. If A is 1, 2, B is 3, 4, the number of subsets of A cross B. Number of subset of A cross B. So we'll find A cross B first. And let's understand how to write A cross B first. Okay. You take element 1 and map it with 3. Then you take element 1, map it with 4. Element 2, map it with 3, and element 2 with 4. This is the meaning of A cross B, by the way. This is called as Cartesian product. Same we would have got from here also. N of A cross B is what? Remember? N of A times of B. What is N of A, guys? 2 and 2. 2 into 2. Check. 4. So I'm getting number of element in the set A cross B is what? 4. You can check over here also. 1, 2, 3, 4. I don't have to write this actually in the question, but I'm just teaching you. That's why I explain this part as well. This is the meaning of Cartesian product of two sets. This is the actual part of the answer. Okay. This is for number of element in the A cross B. What are they asking? Number of subset of that. So always remember 2 power n of A cross B, 2 power 4. So 8 and 16. Answer is option D. I hope this is clear. Please check. I hope this is clear. This is the Cartesian product. This is the number wala relation, cardinality. This is the answer of with the formula. Question number. Let A be the given set. Define a relation R on A to A by R. Means R is defined like this. A to A. What is the relation given over here? Y equal to x plus 1. Okay. Relation R will be what? Please check. If you take x from the set A, which is the first element as 1, you'll have 2 over here. If you take next element 2, you'll have 3 over here. 3, you'll have 4 over here. Take 4, you'll have 5 over here. Take 5, you'll have 6 over here. If you take 6 and 7, you can't take. Because you can't take 6 and 7. Because 7 is not defined in the codomain. You might be thinking, sir, why not 6 and 7, sir? Because 6 is present over here. Good. 6 is present. You're taking 6 from the set A. But 7 is the 7 coming from set A? Not coming. 7 is not present, hence it is not, hence it cannot be taken like this. 7 is not there, that's why we can't take 6, 7. So 1, 2, 2, 3, 3, 4, 4, 5. 1, 2, 2, 3, 3, 4, 4, 5. And 1, 2, 2, 3, 3, 4, 4, 5, 5, 6. Answer is option B. We can't take the option D, by the way. Clear na? Because 7 is not present in the set A. Check here, defined from R to R. Defined from A to A. Okay? So domain is also A, codomain is also A. Clear na? Question number 4. Which of the following relation given below is the function? What is the condition for function? It cannot be mapped to two different elements. Okay. 2, 1, 3, 1, 4, 2. Makes sense, sir? 2 to 1, 3 to 1. Sir, it is mapped to same element, sir. 2 here, 3 here, and 4 here. Okay. We have here, sir, 1. 2 is mapped to 1, 3 is mapped to 1, 4 is mapped to 2. So what? Both numbers can have same image, but one number cannot have two image. It said cannot have two image. It did not say same image is not there or not. This is the function. So this is the function. This is not there. See, 2 is mapped to 2 is mapped to 2 and 4 like this. 1. This option is wrong. 2 is mapped to 2 elements, so wrong. Here 1 to 2, 2 to 3, 3 to 4, 4 to 5. This is wrong. See, 5 to 6 and 6 to 5 to 7 also. We'll have 5 over here. We'll have 6 and 7. We'll map 5 to both. So also not a function. Not a function. Next, here also, yeah, this is not possible. 2 to 1 and 2 to 3. So not possible. The answer is only, it makes sense as well, option A. Correct now? This is the option A. This was the option C, not a function. This was the option, not a function. And T is also not a function because 2 is mapped to 1 and 3 both. I hope this is clear. Any doubt? If you have, put that in the comment section, okay? I'll answer that over there. Question number 5. Makes sense. Question number 5 now. The domain of the real function is what? Sorry, this is this function, okay? Modulus function taken with minus sign. Domain is what of modulus function? All real numbers. Even if you take minus sign, what will happen? Will the domain change? I can take any number over here. Domain is all real numbers, sir. Domain is what? All real number. All real number means what? Minus 2 plus infinity. All real number means minus 2 plus infinity. Answer is question number 6. Domain of the real function over here. This is a good one. Domain of the function. The question is given like this. I'm looking for value constraint on x. Only problem that I am having over here is 9 minus x square cannot be negative. So always more than equal to 0. If it is inside the root and it is a real function, it cannot be negative inside the root. So I have to take always positive. I'll move on this side. I'll get x square less than 9. Take modulus. Mod of x is less than 3. Mod of x is less than 3. When you take root now, it becomes plus and minus. That's why we do mod of x is less than 3. What it means over here? It means x will lie from minus 2 plus 3. Minus 2 plus 3. How come, sir? Think. Take a value more than 3. Sir, 4. Square 4. 16. Is it less? Take a value less than minus 3. Minus 4. Square. 16 again. Is it less? No. My answer is what? Minus 3 to 3. And we have two options. This B or that D. Look at this. Can I put this as 0 also? Can this be 0? Yes, it can be 0. Root of 0 is what? 0. No problem over there. It means I can put 3 and minus 3. If it was ulta, if it was over here, if this was the case now, then answer will become minus 3 to 3 open bracket. But for this question, this is exception by, this is just an example. Just an example I'm showing you. Just for example, if this was the case in denominator, I cannot have 0 in the denominator, can I? I cannot. If I take 0 over here, it becomes undefined. And 1 by 0 is undefined. But it is in the numerator. So I can take 0 also. So at 3 and minus 3, this is 0. Check. Square of 3, 9. 9 minus 9 is 0. Square of minus 3, also 9. 9 minus 9 is 0. But that is possible. What is my answer? Option D. If it was in denominator, then option B will be the answer. Question number, take this once again. Question number 7. Domain of the real function. Domain of real function is what? This is rational numbers. This is basically rational function. You cannot factorize the numerator, can you? Check. 5x square. No, you cannot factorize this. You cannot factorize the numerator. Correct now? 5x square is there. You can't factorize. What about this denominator? You can factorize this. It will become x minus 1 and x minus 4. How can you say that, sir? Cross check. Minus 1 into minus 4 is plus 4. Now, bhai, multiply these two numbers. What is that, sir? Plus 4. Multiply x and x, sir. What is that, sir? X square. Minus 1 into x is minus x. Minus 4 into x is minus 4x. Becomes minus 5x. So correct. Factorization is right. If this is my function fx, I can take any value except for when this is becoming 0. Correct, na? X can be any real value except for those values where the denominator is 0. That is at 1 and 4. Please check. Put x equals to 1. 1 minus 1 is 0. Whole thing is undefined. I can't have that. That's why r minus 1. Put here 4. 4 minus 4 is 0. I can't have that. That's why from all real numbers, remove 1 and 4. Achha, this bracket is middle bracket. You cannot write small or large bracket because this is the meaning that 1 and 4. It doesn't mean 1 to 4. It doesn't mean 1 एक से 4. It does not mean that. It means 1 and 4. It is elemental bracket, middle bracket. Answer is option A. Done. Check one more time if you are not sure. Question number 8 now. The range of the real function fx 2 minus 3x where x is more than 0. X is more than 0. Okay, sir. X is, sir, more than 0. I want to reach where? 2 minus 3x. I want to reach to 2 minus 3x. Let's do one thing. Multiply with minus sign. Multiply with minus sign on both sides. Minus 1 on both sides. It will become minus x. It will become 0 only. Inequality will reverse. You know the property? You multiply with minus sign, inequality reverses. How do we get that, sir? From here. Now I want to write here what? 3. Multiply 3. Minus 3x into 3 into 0. I'm doing multiply by 3. Minus 3x and 3 into 0. Becomes what? Check this out. Minus 3x is again less than 0. What is the next part? This is the addition of 2. So what are you going to do? Add plus 2 over here and add plus 2 over here. What we are doing? Add 2. It becomes 2 minus 3x is less than 0 plus 2 is 2. It means the range, the output of this function is always less than 2. It's 2 open bracket because this is not equal to from where? From minus infinity. Always less than 2 means minus infinity to 2. Minus infinity to 2. The answer is clearly option B, sir. Is clearly option B, sir. I hope this is clear and makes sense to all of you. Have a look. Have a ninth one. Question number 9. The range of real function 2 plus x square. What is the function given here? 2 plus x square, where x is any real number. Think about it. 2 is a constant. X square means always positive. X square means always positive or 0. X, when you put 0, it will become 0. Other times it's always positive. If you take minus 1, minus 2, minus 15, whatever you take, x square will make it positive. So this x square is always positive or 0. So the minimum value fx right here, minimum can be what? 2. When x is 0. Correct, na? When you put x as 0, it will become 2 plus 0. So that is 2. What about fx maximum value? That's infinity. It's always increasing. Plus, plus, plus. Put 2, plus, put 5, put minus 5, whatever you put, it's going to go positive, positive. What is my answer? 2 close to infinity, open. 2 to infinity, open. E is the answer. Fun? Good question? Okay. Question number 10. Domain and range of signum function. Signum function I just taught right now. Domain is what? Domain is all real, sir. Domain is all real. What about range? Hope you all remember. I just taught right now. Minus 1, 0 and 1. Signum function looks like this. Here closed, here open, here open. Okay. This is 1, this is minus 1 and this is. Range is only 3 numbers. Minus 1, 0 and 1. That's my middle bracket. Domain is all real numbers. So answer is what? Option A. Answer is option. For the class note, you have to use what? Link is provided. Please check the AIO page, right? I've told you already. This is your AIO page. Go over here. You will have to enroll and create our login credentials. If you already have the login credentials, login information, just sign in on this free platform for all of you, okay, to learn in the best way possible. And from there, you'll get your all the notes, okay? Let's go back. Let's go back. 10th A is done. 11th question. Association reason. Okay. The relation R 1 2 2 2 3 2 425262 is a function. Let's check. We have 1, 2, 3, 4, 5 and 6. What? All is mapped to 2 only, right? 2, 2, 2, sorry. All is mapped to 2. 1 is mapped to 2, 2 is mapped to 2, 3 is mapped to 2, 4 is mapped to 2, 5 to 2, 6 to 2. All the images same, sir. So what? It's a constant function actually. This is a constant function. Is it a function? Yes. The function is yes. Assertion is true. Reason: a function is a relation such that no two ordered pairs have same first coordinate or same image. Okay, means over here no value will have the basically no one value will have two different images over there. Okay, same thing it means. So it's true, both of them are true. Yeah. So no ordered pairs will have same pre-image, same first coordinate. It's called as pre-image. Okay, so answer is both of them are true. It explains as well. Answer is option A. It means what? That if you are doing a mapping like this, now let's say this cannot have two different different value cannot have same image. Okay, have same first coordinate. See, these are two different second coordinates. It has same value. So you have 0 comma x and also you have 0 comma, it is x1 and x2 now. So x1 and x2 same value. Getting it? If this is 0 1 and 0 1, again 0 1 1 1 and 3. You can see x1 also is 0 1 and x2 is also 0 1. Got it, right? 7th is B. Question number 12 now. Move on to subjective questions. Subjective questions. Okay. Set A is given, B is given, C is given. I'm looking to find for A cross B union A cross C. We have to find A cross B first, then A cross C, right? Property is there, right? A cross E and C. I can distribute the cross product, the Cartesian product over union, right? What is done over here? So I can take A cross, you can see A is here and here also. So A cross B union C. So find B union C first. B union C, sir, is 3, 4, 5, 6. I don't have to repeat that. That's why 3, 4, 5 and 6. That's my B union C. I want to find A cross B union C, right? So I'll write all these values. One with all the numbers. So 1 with 3, 1 with 4, 1 with 5, 1 with 6. Next number is 2. Same thing. 2 with 3, 2 with 4, 2 with 5 and 2 with 6. Same thing. 3 also. 3 with 3, 3 with 4, 3 with 5 and 3 with. This is my Cartesian product of what they were asking. A cross B union A cross C or A cross B union C. This is the formula. Okay, I taught you this today only. This is done, guys. 12th is done. Question number 13. This used to be asked as P by Q earlier. Okay, simple question by the way. So fx is x square. They are asking us f of 1.1 minus f of 1 upon 1.1 minus 1. Don't subtract it right now. Don't do that right now. Let's check. F of 1.1, what is that going to be? 1.1 the square minus 1 the square upon 1.1 minus 1. This is, sir, a square minus b square. It will become 1.1 minus 1 and 1.1 plus 1 by 1.1 minus 1. This part cancels. You have, what is the answer? 2 point. Add them. Answer becomes 2 point. That's it. Okay, sir. Done, sir. Nothing different over here. Question number 14. Please check one more time. I use the formula of a square minus b square. Nothing else. Okay. Find the domain and range of the function. Domain and range of the function. Difficult? Not at all. Okay. If you remember the graph of this function, mod of x will be like this. Okay. This is the mod of. This is one value. This is mod of x minus 1 from this side. This is 1 minus x. What are they asking? Find domain and range. What is domain over here? Check this out. Domain will be for any value you take, will be always from here to here, right? Basically, all real number. What about range? Range is there from where? 0 to infinity, all the way. 0 to 2-marker question. This is 2-marker. Okay. Question number 14. This is question number 15. Let A be this, B is also given. Okay. Function is defined from A to N. They're asking us highest prime factor of N. Okay, means whatever number we are writing over here, we are looking for highest prime factor. Okay, so let's write, and I'm supposed to find what? Range. Range will be what, bacha? Range will be this set N. Okay, from this part, such a number set. Okay, this is of course given as codomain, by the way. This is actually given as codomain, by the way, but still, only from that set only, no? Okay, so if you write, if you put f of 9, what is the answer? Highest prime factor of 9 is what? 3. Correct, na? Your factors of 9 is what? 1, 3 and 9. 9 is composite. What is the answer going to be? 3. Let's put now f of 10. Highest prime factor of 10 is what? 5. Let's try with f of 11. For this you'll have answer clearly as 11 itself. F of 12. For this you'll have what? Highest prime factor, again 3. Will you write? It's already written, sir. We won't repeat the element. F of 13. What is the answer? Prime factor is 13 only. Highest prime factor. My answer. This is my for range. Please have a look. That's my answer for. Okay. Question number. This is again another question. 3-marker only. Draw the graph of this function. How will you draw the graph of this function? So to draw the graph of this function, we'll take the values if you want to. For x equals to 1, x equals to 2, like that. This is 0, right? At 0, the value is what? Equal to 1. So write this as 1. On this side, what is the graph? So you can see that for positive side, this is what? X plus 1. So it will be like this. How come, sir? Think about it, no? Put x as 1. The value will be what? 2. Put x as 2. The value 3 and so on. What about left hand side, sir? Put as minus 1. What will happen? 1 minus of minus 1 becomes again back to 2. 1 minus of minus 2 again back to same value. With the same graph. Here also you'll have 2 and 3 like this. This is 1 minus x. This is your graph. Yeah. Find the respective x values and plot it. If you want to understand how it's working, because check here. For this graph, what is the slope here, sir? Slope is what? This is acute angle, right? This is, let's say, alpha. And for this graph, if you check, this is the angle beta. Alpha is acute. Beta is obtuse. For acute alpha, tan alpha will be what? In first quadrant. What happens over here? Positive. And for this, tan beta will be what? Which quadrant? Beta is obtuse. So second quadrant. Of course, negative. Tan alpha and tan beta means what? Slope. Tan of the angle means slope. So slope is positive, slope is negative. Check here. 1 into x. Here, minus x. Does it make sense? Just for verification part though. This is not required in the answer. 17th question. These are 3-marker, by the way. These are 3 markers. F defined from R to R, and to find fx given as x plus 1, gx is given as 2x minus 3. I need to find what? Algebra of function f plus g, f minus g, f into g, and f by g. Let's start with the first one, which is simple one, f plus g of x. What are we going to do in this? Start the function x plus 1 plus 2x minus 3. That's 3x minus 2. This is your function value for f of g times of x. Second one, f minus is there. F minus g x. Okay, how do you find this? Difference will take. So x plus 1 minus 2x minus 3 becomes what? X minus 2x is minus x. 1 minus of minus 3 becomes 4. So 4 minus x is your difference and sum for the first two part. This product. What is this? Third one, f dot g of x. See the product of this. So we'll have x plus 1 into 2x minus 3, algebra of function, right? Multiply 2x square minus 3x, and we have 2x minus 3. So 2x square minus x minus 3 is your the fourth one, which is f upon g, the quotient, the division, f by g of x. What will happen to this? Same, sir, in the ratio. We'll have x plus 1 upon 2x minus 3, just that x cannot be equal to 3 by 2. Otherwise, it will become 0, right? Otherwise, it will become 0. Put here 3 by 2, it will become 3 minus 3, which is 0. So, cannot be there. That's the question number 17. All the algebra of functions. Number 18 now. This is the 5 marker, by the way. This is a 5 marker. You have to define the function. So we have defined it already. I'll show you just once. I'll just draw the graph also, okay? Signum function, where is it? Here only, right? What? Signum function. Here, signum function. So I've done this question, okay? This is the definition of the function. This is definition part. This is domain, and this is range, and that is the graph. That is worth 5 marks. So all of these, this one, okay, the modulus function, these are all worth 5 marks. Okay, you have to draw the graph. I have given it already. Okay, I'll not be doing it over here. This has been given to you already. Okay, define the signum function. If you want, I can draw the graph for you for reference. Post, open, and going to be 1 minus 1, 0. So all the way till plus infinity. Over here, all the way till minus infinity. Okay. This is the graph of signum function. Definition is also given. Please refer the notes. Okay. Define the rational function. So this is not given, so I'll teach you this. 1 by x will be the function given over here, provided of course x cannot be equal to 0. Check here domain. They've given the domain very clearly. Okay, what is the domain going to be? Over here, all real number except for 0. What is the range, bacha? Range will be equal to all real numbers over here. Again, range will be also be equal to all real except for 0. It will never reach 0. Range will be also same. Range will be also same only. Okay, so range is, domain is all real except for 0. Range is also all real except for 0. How does the graph look like? Okay, this is the graph. Goes all the way up. Here also arrow is there. Represents minus infinity, represents plus infinity. This also minus infinity. Right here is. We have the graph as odd function, symmetric about origin. This is the odd function, by the way, right? This is the odd function. Okay. Put some more hard work. Work around this question. It is very, very important. You get over here 5 marks. Okay. So I've given you hints and help to solve all these questions. But yeah, got it. This is done for the second chapter. Let's move on to next one, which is trigonometric function. Moving on. Yes, so this chapter is trigonometric function. Again, very important for the point of view of formulas, because Usually we miss out on that, but don't worry. Today in the session itself, I'm going to give you list of all those. So let's look at what the session looks like. So I'm going to solve total 16 problems over here. First 9 will be your MCQs. Then you have 2 and 3 markers. Then I brought some 5 markers as well. Okay. Then let's move on. So guys, as I mentioned already, for all the notes and everything, this is our platform for all in one page. This is a next level of classroom learning, and this is all available for free for all of you. Okay, just what you have to do, go and click on the link provided in this particular session. You'll find down there as free ACE 2027 series. Okay, you click on that link and you'll visit this page, enroll, create your login credential and start learning with us. Okay, so this is your, again, let's look at some of the way basics to the different identities that is there in trigonometric functions, starting from angle measurement, right? So starting from this, because the questions like this also is there, the conversion of questions are also there. I've taken those as well, I'll show you. So conversion questions with this will help, 1 degree is 60 minutes, 1 minute is 60 seconds, and the angles are there. Okay, the conversion formula means when you're going for degree to radian, pi into 180, opposite it 180 into pi. We'll use all of that. Some of the standard results are also here, please check. Okay, so 30 degree will become what? If it is 30, let's try to find this using this result. If I have 30 degree, what's the result saying? Into pi by 180. If you want to convert from degree to radian, multiply by pi by 180. Let's do that. 30 degree, so 30 times 6 is 180, so pi by 6. Am I getting that? Yes. So this is the formula, pi by 180 if you have to convert from degree to radian, whereas from radian to degree, just opposite, means just reciprocal, 180 by pi. Clear? So same results is displayed over here as well. Let's move on. These are some simple ones. We'll quickly go through that. We'll not spend much time on it. Of course, this notes will be very much important for you, so please try to utilize it. Okay. Then we have some ratios, the ratios of sine, cos, tan, cot. Okay, and the reciprocal relations of sine and cos. Very simple ones. Let's not waste our time over here. Basically based upon the right angle triangle. Standard results that you have, the standard values of the angles at different values, sine theta, cos theta, tan theta, all of the 6 for the angle 0 to 90. Okay, and of course, how do you remember that? Please check. Just simply write this as 0, 1 by 2, 2 by 2, 3 by 2, like that. You'll get the answer. This is nothing but also written as sometimes, mostly actually 1 by root 2, both of these. 1 by root 2. So how you remember that? 0 by 2, root 1 by 2, root 2 by 2, root 3 by 2, root 4 by 2. That's your value for sine for angles 0, 30, 45, 60 and 90. Okay, but I think you all know this very well. Moving on. Sines in different, basically your different quadrants, basically the quadrant rule, right? So the condition is ASTC. We have a acronym also, like how to remember that? Add sugar to coffee. Add sugar to coffee. What it means by A? First quadrant all, second quadrant S, so only sine and the reciprocal. Second is tan, so tan and reciprocal. Last is C, so cos and reciprocal. So add sugar to coffee. This is your acronym. So remember, all the 4 quadrants which all are positive. Means in the first quadrant, all 6 trigonometric ratios are positive. In the second quadrant, sine and the reciprocal, which is cosec, is positive. In the third, only tan and the reciprocal, which is cot, is positive. In the last, fourth quadrant will be cos and secant will be positive. Okay, so remember like this ASTC, or basically add sugar to coffee. Okay, some fundamental identities that you have already learnt in grade 10. Sine square plus cos square is 1, 1 plus tan square, 1 plus cot square. Different forms of them, because they are also used at different questions. Okay, so different forms. Sine square is 1 minus cos square, same way cos square is 1 minus sine square. This is very extensively used. Secant square minus tan square is 1, and this also cosecant square and cot square difference is 1. Okay, then the range of the functions, basically domain and range. I'll give you the list of that, don't worry about it. So range of the functions. Periodicity means sine and cos are periodic over 2 pi value, periodic in 2 pi, sine and cosec, but tan is periodic in pi. Okay, for sine, cos and cosec secant, it's 2 pi, tan, cot is pi. Periods are given. Okay, period of the different trigonometric functions. Okay, allied angles, this is very simple, right? For negative angle, sine of minus theta is minus sine theta. Why sir? Why sir? Because it is odd function. So odd function, this is even function, this is also odd function, this is also odd function, even function, odd function, right? The negative of the angle. You can understand from that concept or basically in the fourth quadrant concept, because if I draw the angle minus theta, theta is this, right? This is the minus theta, correct? Na? In minus theta, which quadrant is this, bacha? This is fourth quadrant. In fourth, only cos and sec are positive. Only these two are positive. So clearly check here. Cos and sec are positive. Rest all will be negative. Makes sense? Yes. This is the second quadrant getting the pi minus theta. So it remains sin pi minus theta is sin theta and all of that. I hope you all know anyway. Just understand this. At the multiples of pi, what will happen? Trigonometric ratio remains same. Okay, when it is pi, 2 pi, 3 pi, 4 pi like that, it will remain same. Sine will be sine, cos will be cos. And they look at the angle, whether the angle is in first quadrant, second quadrant. So pi minus theta is in which quadrant? Second quadrant. Sine is positive. Cos, second quadrant, negative. Tan, second quadrant, negative. That is clear, right? But for multiples of pi, which is pi, 2 pi, 3 pi, 4 pi, the trigonometric ratio will not change. But for odd multiples of pi by 2, odd multiples of pi by 2, what it means? 1 pi by 2, which is basically pi by 2, 3 pi by 2, 5 pi by 2, these are odd multiples of pi by 2. What happens over there? The function will change it to complementary counterpart. I'll show you, don't worry. This is for the third quadrant, we write here pi plus theta. This is for fourth quadrant, which write here 2 pi minus theta. Okay, the relations are same. So it will remain as it is. Check here. All of this remains as it is. Sine is sine, cosec is cosec, sine is sine, cosec is cosec. So at the multiples of pi, trigonometric ratio will not change. Okay, but at the multiples of pi by 2, see here, pi by 2, pi by 2, 3 pi by 2, what is happening? Sine becomes cos, cosec becomes sec, tan becomes cot. Same is here also. Sine becomes cos, cos is sine, tan is cot, tan is cot. So at the odd multiples of pi by 2, what happens? The function changes. How does it change? Sine to cos, cos to tan, tan to cot and sec to cosec. Why it is that? Because they are complementary ratios. Okay. And how will the sign look like, sir? Minus plus, depending upon the quadrant rule, ASTC. Okay, clear. Because check here, 3 pi by 2 minus theta is what? Which quadrant? Second quadrant, right? Sorry, third quadrant, right? So cos is negative. Tan will be positive over here. Yeah. And the sign that you are applying will be applied on the operating ratio, not on the resulting ratio. For example, tan you are applying over here, that's positive. Let's look at a better example. Let's look at example of this one. Okay. So sine of 90 plus theta, which quadrant? Second quadrant. So at 90, let's look at this very clearly. Sine of pi by 2 plus theta. So at pi by 2, what will happen? It will become cos. Pi by 2 will become cos. Clear. Sine plus or minus, sir? The cos is negative because this angle is in second quadrant. This is in second quadrant. So cos is negative. But we won't take negative because sine is positive. So we'll take here plus sine. But if you apply cos of pi by 2 plus theta, what will happen over here? Cos becomes sine. This will be negative because when you check for the sign, means plus or minus sign, you have to check on the operating ratio, not on the resulting ratio. Okay, operating is sine over here. This angle is in second quadrant. Now you apply the quadrant rule. So sine second quadrant is positive. Now cos second quadrant is negative because angle is in second quadrant, hence it is minus. So I hope this is clear. I want to recall one more thing. Multiples of three things to remember over here. First point is multiples of pi, basically pi, 2 pi, 3 pi, the trigonometric ratio will remain same. Sine will be sine, cos will be cos. How to take the sign, plus or minus? That depends upon the quadrant rule. Okay. At the multiples of pi by 2, means odd multiples of pi by 2, not all the multiple, because 2 into pi by 2 is what? Pi. We will take only odd multiples. So for the odd multiples of pi by 2, the ratios will change to its complementary part. Okay, this is sine to cos, cos to cot to tan, and sec to cosec. Okay, how will you take the sine? Sine is always taken. The third point is sine is taken from the operating ratio, not the resulting ratio. This is clear. Have a look. Moving on. Please download the notes. Okay, this is very important. Sum and difference formula. Sum and difference formula. Okay, sum of the angles. Okay, this is sum of the angles, sine of a plus b, cos of a plus b, tan of a plus b. The formulas already you know. Difference again, you already know. Please remember this, right? Sine a plus b, sine of a into cos of b plus cos of a into sine of b. Likewise, it is for cos. For cos, here it is plus, it becomes minus. Both of them will be the same ratio, cos cos, sine sine. If you take cos negative, will become plus. Ratio will be cos cos, sine sine. Tan, these are very commonly used. These are some special cases when we use it. Cot also at times. Cot of a plus b is, it will be just ulta part. So if you check over here, this difference was in numerator. This will come in the denominator. Difference and sum will come in the denominator. This is cot of a plus b, it becomes cot b plus cot a. If you take cot of a minus b, it will be cot b minus cot a. It is not cot a minus cot b. Cot of a minus b is cot b minus cot a. It is not cot a minus b. So please be careful. Okay. Then again, this is the formula. Difference formula is there. I have taken a question on this from your question bank. Sin square a minus sin square b is sin of a plus b into sin of a minus b. Cos square a minus sin square b is cos of a plus b into sin or cos of a minus b. I'll repeat again. If you have sin square minus sin square, then take the angle sine, take the angle sum and difference in sine. Sum angle, difference angle in sine. But if you have cos square minus sin square, you have to take what? Both cos, sum and difference in cos. Okay. Double angle formulas, very simple, right? Sin 2 theta in terms of 2 sin cos, okay, in terms of tan also is there. Okay, so don't forget the tan wala part. Tan is very important. Very extensively used in your substitution questions. So right now it might not be that useful, but later it will certainly help you. Okay, cos 2 theta formula, okay, just in terms of cos square minus sin square, in terms of cos square, in terms of sin square, all of these are very important, all four. This set of the formulas are extensively used. Okay, then power reduction formula, basically writing sin square in terms of, there the power is 2, here the power is 1, angle is half, here the angle is double. Okay, so all these half angle, triple angle, all the formulas are very important. Okay, given you all here, please take the notes and learn all of them, remember all of them. This is the case of product to sum. Okay, here we have product of ratios, we convert it into sum. 2 sin a cos b, sin of a plus b plus sin of a minus b. Okay, same thing is ulta over here, sum to product. This will be divided by 2 everywhere. Sin of c plus d is 2 sin c plus d by 2 into cos c minus d by 2. Again, we can derive both from each other. This we can derive from here, this we can derive from here, but not required. Generally, let's look at some cases for equations also. So if you have a case of sin theta is 0, which will be the answer? The general answer is theta equals to n pi. For any multiple of, any integral multiple of pi, sin theta will be cos theta is 0 when? For odd multiples of pi by 2. 2n plus is odd, na? This is called as odd multiples of pi by 2. This is what? This is called as integral multiples of pi. Okay. Same thing over here also for tan theta. This is for when you have sin theta equal to sin alpha, then you have to go with this method, n pi plus minus, either write minus power n or plus minus alpha. See over here also. When you have cos square equal to cos square alpha, then you have this condition. Tan square equal to tan square alpha, again n pi plus minus alpha. Okay, n pi plus minus, please check. This is for solving general equations in trigonometric functions. Basically trigonometric equations, not function as it is. This is the domain and range and their respective periods. Okay, yeah, sin cos, cosecant sec, tan and cot is pi. The periodic function is there, that's why the periods are written over here. Okay, domain and range are clear. This is very simple, right? Please remember, this is not for inverse function, this is for sine function. So all real over here except for the odd multiples. Sometimes MCQs directly these kind of questions are expected. I'll show you that as well, don't worry. Okay, moving on. These are some very commonly used formula. So I've already given you all previously, but these are must remember. These are must remember. This is very commonly, very extensively used formulas. Okay, means these are used more often than you think. Means at least this all should know. All of this should be present. Okay, and all of this has been taken from reference of your NCERT textbook. Solving question number 1. Let's start solving the questions now. So all the formulas I have given you guys, please make use of this. I'm very sure that you'll be well prepared. 6 radians in degree. 6 radians. So how do we convert radians to degree? Radians to degree, 180 by pi. 180 by pi. Radians to degree, right? So this is, so we multiply with 6, correct na? So 6 into 180 by 22, the 7 goes up. Correct, right? Yes, 180 into, yeah, radian to degree is this. So how do you cancel it? You can calculate this. You'll have here 3, you'll have here 11, right? Let's multiply each of these now. So we get over here what? In 3s are 54, 540 into 7 by 11. Let's multiply, because you have to get to a close value. You can see all of these are very close. So first is 3, that is sure. You have to find the next number, whether it is 3, 4, 3, 3 or 3, 2 or 3, 5. You'll find that, no problem. Let's multiply. 7 4s are 28, carries to 3780 by 11. Check here. If you divide over here, you'll get what? 11 3s are 33. Then you'll have what? You'll have here left as, you'll have here 4 left, na? 33, then 4 is left. So 48. 11 4s are 44. Correct, na? Then we'll have again 4 left. Then you'll have 11 3s are, right? So this makes sense. Something will be there. A fraction is coming. But my point is, this is there, right? This much is there. So I'll show you if you want to know. See this, 3780 is there, right? You do this from here, 11 3s are, right? That's 33. The remainder is 4 over here, 48. 11 4s are 44. Okay, this is how much? So again 4, 0 will come, 11 3s are 33. As I said, 3 4 3 is there. Of course, remainder will be how much? 7, right? So 7 by 11. But what is the point? Approximately it will come as 343 or 344. There is no 344. Please check. 344 is not there. Otherwise, I'll take the 344 value. Approximately, what is the answer coming as? Option A. Approximately, the answer is option A. The important thing over here is to find the second digit. You can see first digit is everywhere 3. Second digit is what? 4. Question number 2. This is a fill in the blanks type of question. Okay. Converting 22 degrees. So this is basically, let's say, a fill in the blanks question. 22 degrees 30 minutes in radian measure. Okay. So let's understand this. 30 minutes means half a degree. In 1 degree, we have 60 minutes, right? I did the conversion. So half a degree will be having how much? 30 minutes. I did the same thing over here. It means that the given question is 22 degrees plus this is half a degree, right? Which is 0.5 degrees. It becomes what? 22.5 degrees. All of you agree? Correct, no? 30 minutes means half. So this total, if you take 22.5 degrees. Can you remember this is half of something? What is that? 45 degrees by 2. 45 degrees by 2. Yes. 45 by 2 is 22.5, sir. Yes, we know that. 45, we remember a formula I gave you. Pi by 4 is 45 divided by 2. What is my answer, beta? Answer is pi by 8. No need to calculate and convert and all of that. Okay, simple. Logic. Answer is fill in the blanks, right? So we can write here simply pi by, clear na? Pi by 8 is the answer. Question number 2. Question number 3 now. A wheel makes 60 revolutions in a minute. So 60 reps, how much time? In 1 minute. Number of radians does it turn? Means what is the angle swept in 1 second? Okay. 1 minute means what? 60 seconds. Correct, na? 1 minute means 60 seconds. So what is the revolution then? 60 reps in 60 seconds. So in 1 second, you'll have how many reps? You'll have 60 by 60 reps. Basically, in 1 second, you'll have 1 revolution. They're asking us, what is the angle swept in 1 second, right? They're saying in 1 second, it goes from here to here, 1 revolution. How much is that angle? 2 pi. In 1 second, In 60 seconds, which is 1 minute, it goes 60 revolutions. In 1 second, it goes 1 revolution. It means it is the complete circle. Answer is 2 pi radians. Answer is a simple question. 2 pi radians. Okay. Question number 4. This is clear, right? Which of the following is incorrect? Okay. So this is correct, right? Cos pi is -1 is correct. Sin pi is 0 correct. Sin 3 pi by 2 is -1 correct. Third quadrant na. Oh, this is the incorrect option because cos pi by 2 is what? Is 0. This is wrong statement or incorrect statement and correct option. So answer is option D. Yeah. Next, as I said, questions do come like this. Okay. Domain and range wala question will come. So please remember the entire table of domain range of all 6 trigonometric functions. Domain of cosec. Cosec is not defined when sine is 0. Correct, na? When sine is 0, cosec will become 1 by 0, na? We will not define that. So when is sine 0, sir? Sine is 0 when? When? At n pi. So from the all real number, remove the n pi. Answer beta, option B. Clear, right? Sin pi is how much? 0. So cosec pi will be what? 1 by 0, undefined. Sin 2 pi is again 0. Cosec 2 pi will be again 1 by 0, so undefined. So from all the real numbers, remove the integral value or integral multiple of n pi. If you are not sure, please check the table I gave you. Answer is option B. Okay, right? Next question. Which of the following is not correct? Again, not correct. Very important. Okay, incorrect statement I'm looking for. Fourth quadrant, sine function increases from -1 to 0. Fourth quadrant. Fourth quadrant. This is 3 pi by 2. This is 2 pi. Sine of this 3 pi by 2 is what, beta? This value is -1. And sine 2 pi is what? That's 0. So increases from -1 to 0. That's correct only. -1 to 0 is increase. First statement is correct. Second one. Third quadrant, cot function is increasing. Third quadrant, which one? This is pi to 3 pi by 2. So cot pi is how much? Cot pi is undefined, right? Cot pi over here will be undefined, and this will be what? Cot, this will be 0, right? Decreasing actually. Let's look at the graph of cot. Cot graph. So tan is like this, na? The cot graph actually. This is 0. This pi by 2. Okay. And again we'll have like this. What? 3 pi by 2. Right? Point will be pi. They are saying that they are asking us to find out from pi to 3 pi by 2. Correct, na? Third quadrant is pi to 3 pi by 2. What is happening? What is happening to the cot function? It is decreasing. It is decreasing from where to where? Towards infinity. Decreasing from infinity to 0. The option says increases 0 to infinity. That is wrong, right? So this is my incorrect option. I hope you are clear. You need to be very good in conceptual and the graph understanding to get the question. Okay? But you can understand from here also. Cot pi is what? Undefined, infinity. And cot 3 pi by 2 is what? 0. They're both positive only, right? 0 doesn't matter. This is positive only. So third quadrant cot is positive, right? Yeah. It's going from plus to minus infinity. Plus to minus infinity. If somebody is thinking, sir, pi over here, sir, cot pi is not infinity because it can be negative also. Now, this value can be in the second quadrant also. We cannot find the cot value at pi. It's undefined actually. Check here. If you approach cot, if you approach the pi from right hand side, it is positive. From left, what is it? Minus infinity. If you approach this from here, you will get what? Minus infinity. From here, you will get what? Plus infinity. Okay, but this is the movement. What is the movement? Third quadrant is the movement. What is positive only? So what happens over here? If you don't know, understand that part, remember the graph. Cot pi to 3 pi by 2 graph is decreasing from where to where? Infinity to 0. This is 0, right? So answer is The incorrect option is, what is it? Option B. Because what is actually happening over here? Decreasing from infinity to 0. This is for cot function. Makes sense, guys? Option B is correct. Another fill in the blanks for all of you. Cot x is 3 by 4 lies in third quadrant. The value of cos x is what? Cot x 3 by 4. Third quadrant, positive only. This will be what? 3. This will be 4. This is my x. I want to find cos x. Be what? 5 is Pythagorean triplet, right? 3, 4, 5 is the Pythagorean triplet. So this is 5. I want to find cos x. It will become 3 by 5. Which quadrant is this? Third quadrant. Cos is negative there. Answer is minus 3 by 5. Third quadrant, cos is negative. Cos is negative there. Answer is what? Minus 3 by. Please check. Question number 8 now. Sin n plus 1, sin n plus 2 times of x, something is like that, right? So I can assume this to be, let's say, sin, let's call this to be alpha. I'm taking alpha as n plus 1 times of x and beta as n plus 2 times of x. So sin alpha, sin beta plus cos alpha, cos beta. This is the formula, right? Cos of alpha minus beta. Cos of alpha minus beta. Write that. Cos of n plus 1 times of x minus n plus 2 times of x. Please expand this. We'll have cos nx minus nx plus x. Let's do one thing. We'll take the x common, okay? So we'll have over here n plus 1 minus n minus 2. I've taken the x common from both the brackets, okay? Check here, n and n is cancelled. Taking here value as cos of x times of 1 minus 2, which is minus 1. That's cos of minus x, and we all know cos of minus x is how much? Plus cos x. What is the answer? Plus cos x. He's right, no? Easy question. Simple problem. Okay. Question number 9. The last of your MCQ. And 1 marker basically. So domain of sin x. That's all real number. It will be all real. So you can take here option 3. Domain of cot x. When tan is infinity, which is pi by 2. So remove the pi by 2 from there. No. When tan is 0 right now. Sorry. Domain of cot x will not have the value where tan is 0. So remove the tan 0 values, which is n pi. So answer is simply 1. Range of cos x is 2. My answer is 312. 312. 312 is option. Done, right? Simple. As I said, list of the domains and ranges very helpful. Now time to solve our 2 markers, 3 markers over here. And I have some 5 markers as well, so we'll solve that as well. In a circle of diameter 40 centimeters, the length of a chord, okay, diameter is 40 means this is 20. Diameter is 40. Diameter is 40 centimeters. So your radius is how much? 20 centimeters. The chord is also given as 20 centimeters. This chord, 20 centimeters. This is going to be what? This is going to be equilateral triangle. Equilateral triangle. Okay. So what is this angle going to be? 60 degrees, because all the angles are 60 degrees. They're asking us find the length of minor arc. They're asking us to find the value of this length, this arc length. Call it to be L. What's the formula for that? Length of arc is r times of theta, but theta must be in radians. That's difficult, right? Of course not. Radius is 20. Theta and radius will be what? Angle 60 degrees, pi by 3. Okay, continue. We'll have 20 times of 22. Okay, Don't have to do that. I need to find the approximate value, right? Okay, let's do 3.14 upon 3. Okay, so we'll have over here this value as, check this out, we have again 100. We get how much is it coming? It's coming as 2. Let's cancel the 0, 0. We have here 2 upon 10. Let's divide 314 by 3. Let's divide 314 by 3. So 3 ones are 3. Then we have 0. 3 for the 12. Then we have remainder as 2. 3 6 are 18. Again like this. Multiply. 6 into 2 is 12. 6 into 2 is 12 and then 13. And we have 2 into 4 is 8. And 1 is carry, so 9. Then we'll have over here, what is this going to be? 0 and 2. 209.32 by 10. That becomes 20.932. Calculation you can do on your choice, okay, whether you want to go with 22 or 7, but this is your answer. So approximately answer is what? 20.9. It's the arc length, so I'll have to write in centimeters only. 20.9 centimeters. If you go with 22 by 7 over here instead for the pi value, you'll have maybe a little bit more, 20.94 or something like that you'll have. This is 20.93 now. It will become maybe 4 maximum. Okay. Simple question only, right? Formula is L equals to R theta. But theta must be in radians. Question number 11 and 12. This is 11th and 12. Prove that cos power 4 minus sin power 4. Let's start with the 11th question. Cos power 4 theta minus sin power 4 theta is what? Something. Cos 2 theta. We have to prove this. This is the formula a square minus b square. We have to write this in terms of course, what? Let's do one thing. Let's write it over here only. Write this. It will become what? Sine cos square sine square, the whole square. This also has whole square. Okay. And for now, we'll remove. This becomes what? Cos square theta minus sine square theta. This is direct very. Okay, great. Cos square theta plus sine square theta. This value is 1. This value is what? The formula cos 2 theta. This is 1, right? That's proven. This is equals to the, this is your LHS, that's your RHS. Done? Simple question. Actually, there's a mistake in the second part. Let me correct that. This is what? Theta by 4, I think. This will be theta by 4. I'll solve it for you. I will solve it for you, sir. All of you respected friends. Let's solve this question. Simple one. This will be again using C. The problem over here is, what's the problem? The root is the problem. Okay, let's go. Just keep this 2 as it is, and you'll have a understanding when you take this 2 common. This is our instinct, right? 2 plus 2 cos theta is there. Of course, we have to take 2 common. When you do that, you'll have 1 plus cos theta. 1 plus cos theta. That's the formula. 2 sine square, sorry, 2 cos square theta by 2 comes. I remember. Yes. 2 cos square theta by, and we have another root over here. So you have to write the steps over here, guys. Okay, if possible, write the formula also on the right hand side. Okay? You'll not get any mark deducted. If you take the root, get what? 2 is left because you have 2 square, so 2 is left. Cos theta by 2 plus 2 is there. Take again 2 common. You'll have 1 plus cos theta by 2, right? And this will become what? 2 times of 2 cos square, one more time, was half of the half angle, so by 4. This will be what? If you take the root, 2 cos theta by 4. Please check that is your RHS. This is your RHS. This is the recent question bank, so I have gone through it, looked at NCERT and found this question very useful. That's why I've solved it over here. I hope it makes sense to all of you. Right? Okay, so 13th one. Next one. This is a simple based upon your crystal angles. So So we have 2 sine square 3 pi by 4 is there, right? Sine square 3 pi by 4 is there. If you look carefully, yeah, sine 3 pi by 4, we have to check, this angles and where is it lying. So actually it lies in second quadrant only, is positive. But even if it is something else, doesn't matter, because we have sine square over here. So whether it was minus or plus does not matter, it will be always squared. In this case it is positive only. In this case it is positive only because it is in second quadrant. And in second quadrant sine is positive. But still, even if it was negative, because of the presence of square, this becomes positive itself. It's not 1, right? It will be 1 by root 2. It will be 1 by root 2 because, yeah, it will be 1 by root 2. Same thing. And over this, secant square pi by 3. That's cos 30, right? Root 3 by 2. Root 3 by 2. Or 2 by root 3. Check. No, that's root 3 by 2 only, not 2 by 2. So, root 3 by cos 60 is there. 1 second. No, this is not. I have 2 square. Sorry, forgot the angle. My bad. Now, square it up, you get 2 times of 1 by 2, 2 times of 1 by 2, and 2 times of 4. 2 or 2 cancels. This also cancels. You have 1 plus 1 plus 8. That's 10. That is equals to cross check RHS. Okay, simple question. And also 14th one. Prove that sine 2x plus 2 sine 4x plus sine 6x is cos square of x plus sine 4x. So guys, you can see over here we have presence of 4x over here. This is also present. So we don't have to disturb this. Let's not disturb it. But this too can make something for us. Try that. Sine 2x plus sine 6x together and sine 4x over here. I'm talking about only LHS, by the way. Let's take only LHS. Sine A plus sine B, that's the formula. Right? We'll have over here sine of sum of these two angles, so 2x plus 6x by 2. And if you go with cos, you'll have cos of 6x minus 2x by 2 plus sine. Correct? Let's go about it. You'll have 8 by 2 is 4, so sine 4x, and you'll have cos 4 by 2. That's going to be what? 2 only. So cos 2x plus sine 4x. We have this common. So if you write the steps, take sine 4x common, right? What we are left with? Over here we have 1 left, and over here we have cos 2x left. This is cos 2x left. Here, 1 plus cos 2x has a formula, if you remember. That is a formula. What is the formula for this? 2 cos square of x, right? 2 cos square of, simplify please, you'll have 2 cos square of x sine 4x, which is nothing but your, I think RHS, 2 cos square of x plus, sorry, into sine 4x. How do we get this formula? We have to use presence of sine 4x. Let's not do that. And sum of the angles divided by 2 will give me 4x. That's why we can have the idea to do this. 15th one. This is the same formula question, right? If you have sine square and sine square, you want to prove this. This is a formula. Sine of the sum of the angles 6x plus 4x into sine of difference of the angle 6x minus 4x. You get sine 2x over here, sine 10x. Correct answer. Or convert this. Method number 1. Method 2 you'll look at. We'll convert sine square and of both the angles in terms of cos. Because we have a formula for that. What do we have? 1 minus cos 12x by 2 minus 1 minus cos 4x is there, na? So 8x by 2. Why we are converting like this, sir? Any idea? Because you have squares over here and there's no square present on that side. That's why. Check. Take the LCM. You'll have 1 minus cos 12x. This will make minus 1 plus cos 8x. Minus 1 plus 1 cancels. You have cos 8x minus cos 12x by 2. Cos 8x minus cos 12x by 2. Correct? Correct? Formula of this 2, very simple, sir. Cos A minus cos B. This will become, one second, sine of sum of the angles. You'll have 20 x by 2 into sine of difference of the angle 12x minus 8x by 2, right? Sum of this 20, difference is 4 basically. We'll solve it. Problem. Sorry, this will be 2 over here. So cos A minus cos B is 2 sine A plus B by 2 and sine B minus A by 2. Okay. So when we go about this, we get 2 and 2 cancelled. Sorry, we have over here sine 20 by 2, that's 10x, and 4x minus 8x is 4x again, divided by 2 is 2x. So sine 2x. So if it is a 3-marker question, even 2-marker, try to use this method. If it is MCQs, you can use this method to get the result based upon this relation. So both of them are correct method only. So let's solve some 5 markers. This is about 5 markers. Correct now? This was question number 15. Let's look at 16 and question number 16. Prove that sin A plus sin 2A plus sin 3A divided by cos A plus cos 2A cos 3A is tan 2A. How do you solve it? Let me give you a hint for this question and you try to solve it. Okay, I'll give you appropriate hint, don't worry. So I want 2A, sir. I have already 2A, 2A. So let's not disturb that. Also, sine of A plus sine of 3A. If you add the angles, it will become 4A. We'll keep it like this. We'll club over here sine A plus sine 3A together and this sine 2A together, divided by cos A plus cos 3A plus cos 2A. That's my LHS. I have just rewritten it, basically rearranged it, nothing else. The formula of sine of A plus sine of B shall be what? Sine of sine A plus B. You'll have 2. Have 2 of course, and you'll have sum of the angles. So we'll have A plus, excuse me, you'll have A plus 3A by 2 and you'll have cos of difference of both. You'll have basically 2A by 2 plus sine 2A. That's the numerator. Same way for the denominator, you'll have 2 sum of the angles, so cos of again 4A by 2 into difference of the angle in terms of cos only, so you'll have cos of again 3A minus A by 2 plus cos, simplify this, you can see over here this is going to be sine 2 sine 2A and cos A plus sine 2A, and over here we'll have 2 cos 2A into cos A plus cos. You can see we have sine 2A common and over here we have cos 2A common, right? Nothing else, so just do that. Take sine 2A common. You'll have 2 cos A plus 1. I know I wanted to give you guys this as homework only, you should try, but it's the exam time. I don't want to give you, especially in trigonometry, some tasks. Let's see if some simple question comes. This is also a simple only. 2 cos A plus 1 and we have, right, yeah, we have cos 2A common. Also we have 2 cos A plus 1. 2 cos A plus 1. This cancelled. Sine by cos is tan. That is my, look carefully, RHS. That is my R. Okay, sir. Done, sir. Moving on. Let's move on. Question number 17, right? Number 17. This is a good problem. Okay, so if x over here is in second quadrant, then x by 2, cos x by 2, everywhere it will be in first quadrant, right? But you have to be careful finding values for cos and all, because cos will be in what? Negative over here. Let's find cos first. Let's find cos, because to get all these values, you need cos. You need cos. Let's find cos first. Cos will be what? Root of 1 minus sine square x. But you'll take which sign? Plus or minus sign? You'll take minus sign, because if the angle x is in second quadrant, then cos x will be negative. So take the minus sign over here. Take minus 1 minus 1 by 16. That gives me what? Minus root 15 by 16. That becomes minus root 15 by 4. Right? Minus root 15 by 4. That is my cos x. It will be very useful. Please check. Now I want to find what? I want to find the value of sin x by 2. Remember this? Sin square x by 2 is what? 1 minus cos x by 2. Correct? 1 minus cos x by 2 is sin square x by 2. So clearly my value for just sin x by 2 will be what? Root of this. So go about it. 1 minus cos this value. So it will become minus of root 15 by 4 upon 2 in the root. So far so good. I've just put the value for cos x from here. It becomes, if you check, 1 plus root 15 by 4 upon 2 in the root. So my sin x by 2 value is coming equal to, take LCM, 4 plus root 15 by 8. 4 plus root 15 by 8. If you multiply 2 everywhere, it will become actually whole square. So let's do one thing, multiply 2 by 2 to the whole thing. You have sin x by 2 equals to 8 plus 2 root 15 by 16. This becomes what? 8 plus 2 root 15 by 4. This is your answer. This is your answer. But you can simplify this further. Any idea how? So whenever you have this kind of form, a plus 2 root, some number is there. Okay, a plus 2 root b, something like that is there. Try to look for two numbers. Try to look for two numbers whose product is 15 and sum is 8. I'll again say, if you have this form, this is very crucial. Okay, if you have this form, a plus in the root, a plus better. You have in the root x plus 2 root y, x plus 2 root y. Try to look for two numbers where a plus b is x and a into b is y. A into b is y, and then the answer will become what? Root of a plus root of b. Root of a plus root of b. How come, sir? Think. I take here 5 plus 3 is 8 and 5 into 3 is 15. This question over here becomes sin of x by 2 equals to root 5 plus root 3 by 4. I hope you understand how it is happening. Because square of root 5 will be how much? 5. Square of root 3 will be how much? 3. So basically you are having a square b square in this only. This 8 represents a square plus b square. And what is this? 2 root 5 into root 3, that is 2ab. It's becoming root 5 plus root 3 the whole square inside the root. I'll give you the clarity. If you are not able to understand this, if you have 8 plus 2 root 15, right? I can write this as root 5 square. Just to show you how it's working, 5 plus 3 plus 2 root 15 is there. Okay, this is sir root 5 square, root 3 square. This is sir 2 times of root 5 into root 3. Check carefully, this becomes what? Root 5 plus root 3 the whole square inside the root. Cancels or not? Yes. What is my answer coming as? Root 5 plus root 3. So if you have a relation like this, a x plus 2 root y, then look for two numbers where sum is x and difference is, product is y. My answer of sin x by 2 is coming as root 5 plus root 3 by 4. So this is something extra. Okay, this is the relation. Let's solve now cos x by 2. Let's solve now cos x by 2. So cos x by 2 is same way, root of 1 plus cos x upon 2. For sine, what was that? 1 minus cos x upon 2. This was cos 1 plus cos x by 2. So you'll have same answer, just opposite. Check here. Have 1 minus root 15 by 4 upon 2. This becomes 4 minus root 15 by 2. Correct now? Correct, right? Sorry, 2 into 4. Correct, right? Anything I'm missing? No. This is going to be root 15 by 4, no? It will become minus sign. Yeah. So 4 minus root 15 by 2 will become, 2 will come down. So 8. Now if you multiply again here also into 2 by 2, you'll have over here 8 minus 2 root 15 upon 4 into 2 into 2. 16 root over here. This will become what? Please check. This over here is nothing but same result, right? Root 5 minus root 3 by 2. This is your cos x by 2. Cos x by 2. Correct, right? So this is the same B. 5 plus 3 is 8. 5 into 3 is 15. So here the sign is minus, so right here minus. Root 5 minus root 3 by 4. That's cos x by 2. Okay. And it will be both positive only, guys, because this is in the first quadrant. That's why we have to take plus sign over here. First answer is over here. Second answer is over there. First is here. Second is over here. I hope this is clear. Last question, pakka. What about tan, sir? What about tan x by 2? This you will solve. Sin x by 2 upon cos x by 2. Nothing is there actually. You'll see this 4 and that 4 will be cancelled. You'll have over here root 5 minus plus 3 upon root 5 minus 3. Just rationalize it. We'll get the answer. This value, you'll have root 5 plus root 3 upon root 5 minus root 3. Rationalize it. You'll get the answer. Rationalize it. Please rationalize it. And write the final answer. Okay. Rationalize this. Okay, you have to rationalize over here. So this I'm leaving to you. Please have a look. The entire question. Done? Yeah. This was your trigonometric functions and questions on that. Let's move on to the last chapter in this session today. Is complex numbers. I hope all of you remember your notes will come in all in one page. Okay. I have given you link link for that in the video description. I've explained you many times. Okay. How to access that? Basically, the link will have ACE 2027 free series. You'll use this link. Okay. Use the link of this. I've given you demo also. Create a login credential. Start using it. It's for free. Your free platform, free classroom experience by Vedantu. Okay. Let's move on then. Questions from this chapter. I brought 8 MCQs, total 13 questions, 2 and 3 markers. I have taken only 5 over there. Here, let's move on. So let's look at the concept part first. Okay. Yes. That's why I'm telling you this notes is very important, because all the formulas, all the important concepts are listed over here. It'll be a good revision for you. Okay. So what do we have, sir, over here? Complex numbers, basics. So very basics. we write complex number z as x plus iy, of course. So imaginary unit, it comes from where? I equals to root of minus 1, right? Root of minus 1 was actually from where we get iota I. So if you do square on both sides, what are you going to get? Minus 1 equals to I square, same value over here. I is not a real number, it's an imaginary number, of course. Real part will be written as real part of the number z, which is just x over here. So if I'm writing in terms of a, that is better. A plus ib. So a represents your real part, b represents your imaginary part, written as real of z and imaginary of z written over here also. Correct now? If you have two complex numbers, then if they're given equal, then you have real part equal and imaginary part equal. Okay. Special cases, of course, this is for purely real when the b is 0, when the imaginary part is 0, and when a is 0, it will become purely imaginary over here. When a is 0, it becomes purely imaginary, and when both are 0, becomes complex number, 0 complex number. Clear, guys? Moving on. Okay. And so this is basically some of the general forms of iota. I power 1 is I square is minus 1, I cube is minus 1, and I power 4 is 1. Okay. One more thing is that if you add 4 consecutive numbers of iota, 4 consecutive powers of iota, you always have the answer 0. I minus I and this and this will cancel. This will also cancel. Whenever you add 4 consecutive powers of iota, answer is always 0. See? Sum of 4 consecutive powers is always 0. In plus 1, in plus 2, in plus 3, always 0. Please remember the standard forms. You'll have some ease of solving question in the MCQ side. Algebra of complex numbers. So addition, subtraction, multiplication, division. A plus IB, you have to add A to C and B to D. So A plus C plus B plus D. Same goes in the case of difference also. A to C and B to D. So A minus C, B minus D. Multiplication is not the case. You have to multiply using what? Distributive law. A with the whole thing, IB with the whole thing. In the case of division, what you have to do? Basically, multiply this with the conjugate of C minus or C plus ID. Multiply like that. Okay. Then it becomes, basically, if you have this, no, A plus IB upon C plus ID, you have to multiply with C minus ID and C minus ID. So basically the conjugate of your denominator complex number. Okay. Properties. So all this law withholds true. Commutative is also commutative, associative. Additive identity is 0 over here, and additive inverse is minus z. So additive identity of z is 0, and additive inverse of z is minus z. Okay. And multiplication laws are same thing, commutative, associative, multiplicative identity is 1. Okay. And distributive law also holds true, as I mentioned over here. Okay. So all the laws are validated over here as well. Multiplicative inverse and divisions. Same thing. This is the inverse part. Z inverse will be what? 1 by z. To find this, you have to do what? Multiply with the conjugate. Multiply with the conjugate. Right now, if you have Z inverse, it means 1 upon A plus IB. To multiply this, you have to get A minus IB upon A minus same thing. A minus IB, which becomes what? A minus IB upon will be A square plus B square. Because always remember, Z into Z bar is what? A square plus B square. Always. Yeah, or basically is called as mod of Z square. Mod of Z square. Yes. Division method, same thing. I already explained it to you in the over here as well. Division is same like this. What we had. Identities, whatever identities you have of algebra, no, A plus B the whole square, A minus B the whole square, all holds true over here also. All holds true over here also. A plus B the whole square, A minus B the whole square, and especially A plus B and A minus B, very, very useful. Very useful. Chapter is not difficult. You know, sometimes we forget the property. That's why it becomes messy or difficult for us. Conjugate of complex number, very simple. If you have complex number as A plus IB, conjugate is A minus IB. Okay. So what it means is just that image about real axis, which is x-axis. Right now, if you look at the Argand plane, so if A plus IB is over here, right, then A minus IB is where? A minus IB is here. So reflection about the x-axis. That's what it means. Properties of conjugate. The double conjugate means conjugate the conjugate. If you have bar on the bar, it becomes original complex number. Some more properties are here. Please go through it. Z plus Z bar is 2. That's the real part. This is going to be imaginary part. This is what I wrote in the previous one. If it is purely real, Z will be equal to Z bar. Okay. If it is purely imaginary, you will have Z will be equal to from here. Z bar will be equal to minus Z. Okay. In case of purely imaginary, you will have Z bar equals to minus Z. Same here. Algebraic properties. You are distributing. This is actually conjugate everywhere. Not visible. Okay. So if you distribute it, you can distribute like this on the sum and difference, also on the product, also on the division as well. Okay, so this is representing your conjugate part. Okay, symbol is for conjugate. Bar means this conjugate symbol is this. That's what we're doing everywhere. Real part of Z is given by Z plus Z bar by 2. Imaginary part is given by Z minus Z bar by 2. This is very important formulas. All are extremely important, guys. These all formulas are very, very important. And yes, you have to remember all of them. You cannot forget even one of these. Very, very important. Modulus of complex numbers. How does it work? Same thing. So Z bar will be Z modulus is given by modulus of A plus IB, and you have to take the squares of the individual values, real and imaginary part, taken in root. Okay. What it implies that it shows that if I have over here point A plus IB, na, modulus means this distance. Modulus means this distance. So basically distance of the point from origin. How to find distance formula? A minus 0 the whole square, B minus 0 the whole square. So modulus means distance of the point in the argand plane from the origin. Okay. Properties again listed over here. Please remember all of these. Triangle inequality is also very, very important. Not that extensively used, but important. Okay. Argand plane and their representations. So if you have complex number Z A plus IB, the x-axis is the real axis. Basically, as I was telling you for this long, if it is A plus, the point is what? If I'm writing a coordinate, no, it is written as A comma B. What it means is this is the real axis, this is the imaginary axis. Okay, this is over here A, this over here is B. Okay, the point. Right? Origin is always 0 comma I0. That's your origin now. In the real planes, what used to happen is 0 comma 0 used to be there, but over here we have 0 comma I0. Section formula and all this holds same way that was there. Mz2 plus nz1 upon m plus n, not that extensively used. Okay, rarely used, but this is used. Distance between 2 points is mod of z1 minus z2, mod of z1 minus z2. Okay, midpoint formula also is here, and some results for perpendicular lines, perpendicular bisector and circle with z0 radius r. This all are little bit rarely used. Okay, this is useful for your competitive examination. What formulas I'm giving you, I thought giving you to over here as well. Why to skip it? This is useful. Okay? A polar conversion form from the Cartesian form. So if you have z complex number, you write this in polar form as r cos plus. Basically, it is r cos theta plus I r sin theta. Like here, the x value, or basically the a value is called as r cos theta and b value is r sin theta. Okay, so your a square plus b square value becomes what? R square. Okay, r square. So the modulus comes from here only. Check here, r becomes, if you find the value of r, it becomes root of a square plus. Okay. Argument is nothing but the angle that you produce. Okay, so this is, let's say, that's my argand plane. Let's say for this point over here, a comma b. You join this. This is called as the angle theta, which is the argument. Okay, over here this will be b and this will be a. So you write here tan theta as b by a. From there only we get tan inverse of b by a as argument or the amplitude. Okay, all done, all written over here. Okay. This theta means r cos plus I r sin theta. So I represents, I is the separation between what? The real and imaginary part. So this means C represents the real part, S represents the, check here, C is for the real part, S is for the imaginary part. Okay. Square root of complex number, not that directly used, but the question like this can come for competitive examination, both CET and for PU, for JEE. So that's why given over here, it's not difficult at all. If you're writing root of any complex number, you'll be another complex number. You take x plus iy, you take the whole square and solve it. You'll have this result. Okay, simple question only. And this is the direct formula, same thing, directly written over here. You can try this out if you want to, but not, I think, directly useful as of now. But it's not something that is difficult in nature. Very easy. I have all the formulas given to you. Please review it. Quadratic formula. If this is the inclusion of the quadratic in the complex. So if you have, this is your quadratic standard form, okay, and you find the discriminant d as b square minus 4ac. Whenever this d value is negative, this is from where the complex numbers come. These two will have only real values. From here the complex number comes, and here only if you have the negative value, no, if the d is, let's say, equal to minus 4, formula is minus b plus minus root d by 2a. You write this as minus b plus minus root minus 4 by 2a. You write this as minus b plus minus, so minus 4 you cannot find, right? You write this as 4i square, right? Minus 4 as 4i square. Now if you take the root, it becomes what? Y. This is going to be minus b plus minus 2i upon. That's how it works. Okay, you see the I is coming outside, and complex roots are always conjugate pairs. Means if it is a plus ib is the root, then a minus ib will be the other root of quadratic equation. So they are in the conjugate pairs. Some factorization, a plus b square is what? A square plus b square is same thing, a plus ib and a minus ib. Result over here. First one is very helpful. This is very, very important. This not so much. Okay. And cube root of, this is also important concept, especially for KCET. So forget about this right now. This you can forget about it. Not required. The Euler's form not required. This is required. This is important. You see, this is complex conjugate. Minus 1 plus, minus 1 minus. These are complex conjugate. If you, how does it come? So if you have, let's say, cubic equation, right? You have cubic equation, which is nothing but ax cube plus bx square plus cx plus d equal to 0. What happens? Sum of roots. Sum of roots will be what? Will be, sir, basically minus b by a, right? If you check the equation, which is cubic root of unity, means x equals to cube root of 1. Take cube, it becomes x cube equals to 1. From here you get x cube minus 1 equal to 0. Now compare this and this. Compare these two. What is the b value? You get b value is 0. If you add sum of roots, you're going to get what? Sum of roots is equals to b is 0 means 0 by 1. That's 0 only. And if the roots are omega, omega square and omega cube, okay. So what happens over here? You simply write this as 1 plus omega square. Omega cube is 1 means what happens over here? Omega is 1, right? So 1 plus omega square will be equal to, that's why it's written over here. Can you see? Omega conjugate is omega square and omega square conjugate is omega. For the CET point of view, it's important, but I have given you this result over here anyway. This is the Euler's form, not that important for your syllabus. Okay, but if you're writing for JEE, it becomes relevant. But for board's point of view, not that important. Quick reference, which is the important formulas. I have given you list and recall of all of this. Important properties or powers of I. You have multiplication of z and z bar, the real and imaginary part, product of two complex numbers, triangle inequalities, finding the inverse of complex number, polar form. This is not that important. Complex conjugate roots. When d is 0, you'll have two complex conjugate roots. Okay, and this is the formula for a plus ib and a minus ib. Unit of unity, this is important, and the argument relation also is important. One more thing is that the theta is equals to tan inverse of b by a. These are important relations. Okay, great. This was the end of your theoretical part. Let's look at some questions now. Again, questions are very relevant because they are from your question bank. Okay. This is where you compare two complex numbers and find the value of x and y. Let's do the expansion over here. We'll have 4x plus this is, you don't have to compare, right? Simply just compare 4x with the 3. You're gonna get what? 4x equals to 3. So x is 3 by 4. I want to find out y actually. Okay, and if you compare this imaginary part 3x minus y with this, you'll have 3x minus y is equals to minus 6. X is 3 by 4. So write it over here and move this. You'll have 3 times of 3 by 4 plus 6 equals to y. I've moved the sign because I want to find the value of y, right? So 9 by 4 plus 6. Take LCM, you have LCM as 4. 24 plus 9, that's 33. 33 by 4, any option like that? Option B. Option is great. Please have a look. Option is question number. The additive inverse of minus 2 plus root 3i. What is the meaning of that? It means if you add z with minus z, it should be coming as 0. That's called as additive inverse. What is going to be the minus z value? If z is minus 2 plus 3i, z negative will be what? Plus 2 minus 3i. Plus 2 minus 3i. That's option A. Please check 2 minus 3i. Option is A. Simple problems. Do let me know how was the session. Of course, we are about to solve the last set of questions, but let me know what you felt about the session in the comment section. Okay, something else I could do to help you out, let me know. Whatever is possible, I'll do that for you. Okay, but please download the notes because I've given you formulas over here only. Okay, the conjugate of complex numbers, conjugate I'm looking for. This is my z minus 5 minus 3i. I'm not looking for additive inverse, I'm looking for conjugate. This will not change, only this will change. Only minus 3i will change to plus 3i. So that's option, I guess, D. That's option D. Number 4. I plus 1 minus I. This is also something that you can remember actually. 1 plus I and 1 minus I if you have. Now remember, this is always equals to I. This is actually equals to I, but still I'll solve it for you. You have to take this as 1 plus I and 1 plus I. Okay. So it becomes 1 plus I the whole square. And over here you'll have what? 1 square and I square. Sorry, 1 square plus 1 square, no? Square plus 1 square, because you have 1 minus I square, it will become simply again positive. If you're not sure, do it. 1 minus I square will become what? 1 square. What this part? 1 plus 1 square, that's going to be what? 2, right? 2. And what about this? You'll have expansion 1 plus I square plus 2i upon 2. Check, I square is minus 1, so they cancel. We have 2i upon 2, 2 to cancel. We have the value as I. As I mentioned, this is given as basically, check here, given as I power n equals to 1. Now to this is possible when n is 4, 8, 12 and so on. So for the multiples of 4, I power n is 1. I'm looking for smallest value. The answer will be option C. Option is C. Okay, I square is minus 1. So I power 4 will be 1 for the first time. So 4, 8, all the multiples of 4 will give me I power as 1. So my smallest value is 4, which is C. Number 5. Square root of minus 3. So this becomes what? Minus 1 into 3. So I square into 3. But if you take square root, it becomes what? Root 3 I plus and minus sign. The answer is, when you take root, you get two answers, plus and minus I. That's not the minus sign which was inside. That minus sign is replaced by minus 1. Difference is there. Okay. Clear? Clear, right? Question number 6. Please watch this session again, download the PDF, review it again. It will be very, very helpful. I need to compare that complex numbers cube with a plus ib and then find the value of a. Let's do it. So 5 cube minus 3i cube, and you'll have what? Minus 3 into 5 into 3i and 5 minus 3i. That's the expansion, right? I'm looking for only real part, right? This is the real part. So I'm looking for only real part. Let's not worry about I power cube and 1, because real will come only when it is I square, I4 like that. Okay. Let's look for real part. 5 cube will be how much? 125. We'll not worry about this. Multiply this with this, you'll have only I. Multiply this and this, you'll get what? Check this out. You'll have 3 into minus 3 into 5 into 3i multiplied with minus 3i. Check this out. 15 3s are 45 minus sign I, and we have minus 3i. 45 into 3 is how much? 45 into 3 is 135. I square. This is what? There's a minus into minus becomes plus. So 135 I square. It becomes what? 135 into minus 1, because I square is minus 1. Minus 135. So this value. This value, you have to take them together. It becomes what? 125 minus 135. How much is that? Minus 10. Why I'm looking for only these two? Because I power 3 will have imaginary part, and I power 1, if you multiply with 5, you'll have 3i into 5, right? I'll be having imaginary part. I'm looking for value of only a. I need to find only real part, that is coming as minus 10. That's my option. I hope this is clear to everyone. Clear, right? Please check. Question number 7. X minus iy root of a minus ib on root of c minus id. You can solve using, taking multiplying this with x plus iy and all those things. You can do that. Okay. Because you need to find x square plus y square, no? This can be reached either multiplying this by x plus iy or what you can do over here is simply take modulus. So in this, if you are having x minus iy, na, root is there. Okay. A minus ib and c minus id. You can simply do what, bacha? Is take root. Take the modulus. Modulus here, and modulus here. You can take modulus on the both sides. It will become what? X square plus y square. It will become what? Please check. A square plus b square on c square plus b. Right? Correct, na? Modulus will give me, actually root will be there, right? You'll have root over here actually. Okay, you'll have root. You'll have root over here, right? So if the root is there, you have to write the root here as well one more time. Correct, no? Correct, right? Yeah, root over here. Because if you're taking root, no, you'll have another root inside this. It'll become power 1 by 4. I can take square though. Let's do that. You'll have over here power 1 by 2. Okay. And 1 second. Let me erase this. 1 second. Actually, you'll have this. You'll have over here x square plus y square, the power 1 by 2. Here again you'll have what? a square plus b square, okay, power 1 by 2. Okay, here also you'll have c square plus d square power 1 by 2, and the whole is also having a power 1 by 2. You combine them, it becomes a square plus b square upon c square plus d square, the power what? 1 by 2 over here, 1 by 2 over here, it becomes 1 by 4 actually. It becomes 1 by 4 actually. And this right here, you have x square plus y square power 1 by 2. I want to get what? Power of over here as 2. Check here right now, power is 1 by 2. I want to reach the power of 2. So I'll do what? I'll take the whole side, basically power of 4. Power of 4. Power of 4. And you can use multiplication also over here, not only the modulus, but since I've gone with this method, I can just continue. Okay. So what I'm talking about the multiplication, I'll tell you that. Just let me finish this. If you do over here x square plus y square power 1 by 2, the whole power 4, that side, a square b square c square plus d square power 1 by 4, the whole power 4. Check. 4 and 4 cancels, this will cancel and you'll have 2 left, getting x square y square the square equals to this value, only this is left, a square plus b square and c square plus d square. That will be your answer, option. That is your answer, option A. What I was talking about in the previous case, you multiply x plus x minus iy, no, into x plus iy, this becomes what? X square plus y square. X square plus y square. It's basically with the conjugate. You can take that over here also. It will become a square and b square, c square and d square. Getting it now? This is the method of modulus. If you want to go with the method of conjugate, so over here you'll have x square, y square, you'll have a square and b square, c square and d square. Correct now? Because if you go x minus iy, x plus iy, you'll go that also, right? A minus ib into a plus ib will become a square plus b square inside the root. Correct now? This is your method 2 I'm talking about. This is your method 2 I'm talking about. Correct? Answer is option A. Question number 8 now, the last MCQ. Z into Z bar. Z into Z bar. This comes as simply the first one. Z bar is what? Z square. That is going to be x square plus y square. We use the same thing. Check here. Z into Z bar is what? This value. X square plus y square. Square plus y square. First one. Z minus Z bar. Check here. Z bar means if it is x plus iy, it becomes x minus iy. Z is given as x plus iy. Look at the question over here. If you do z minus z bar, no, x and x will cancel. You will have what? Simply I to y. Answer will be over here as option 3. Remaining one is 1, 3, 2. 1, 3, 2. That's option D. Carefully. 1, 3, 2 is option B. Right? I hope this is clear. I hope it is clear. Yeah, let us solve more questions. 2 and 3 markers over here. Find the real number x if x minus iy is the conjugate of that. Conjugate of this. Find conjugate of this first. You'll have minus 6 plus 24i. This is my complex number z. This is your complex number z bar. Because this is that value. This is conjugate of that. So I found the conjugate of that. It's coming as minus 6 plus 24i. Let's find this. We have x minus iy times 3 plus 5y. Expand it. You'll get 3x minus 3iy minus i3y, because lying like this. So i3y. Multiply now. Over here we'll have i5x. Right now? I5i into x is I5x, and last one will be minus I square 5y. Correct now? I into I is I square 5y. Okay, simplify this. It will become simply as plus 5y. Correct? we have 3x plus 5y. Over here we have plus I, if I do 5x plus 5x minus 3y, right? That's the complex number. 3x plus 5y, and this is 5x minus 3y is the imaginary part, and this is equals to what? This number minus 6 plus 24. I can get two equations over here. Question number 1, 3x plus 5y is minus 6, and 5x minus 3y is 24. It's 24. That's my two equations. Okay, I can see this is coming as, I can cancel this over here, no, because yeah, this is 5y, this is minus 3y. We'll do what? Multiply this with 3 and this with 5. How come, sir? Look, 5 into 3 will be 15, 3 into 5 will be also 15. Okay. Write this again. We'll have 9x, we'll have 15y, we'll have over here minus 18. 5 into 5 is 25x, 5 into 3 is minus 15y, and this will be what? 25 times 4, that's 120. That's 120. Now add them. Equation 1 and 2. This part gets cancelled. 25 plus 9, that's 34, right? 25 and 9, that's 34x. This is coming as 102, right? 102. Yeah. If you cancel this, you'll get over here 3 actually, right? 34 times 3 is 102. My x value over here is coming as 3. Yes. Is it positive value? Yeah, it's positive. X is coming as 3. X is coming as 3. Let's look at y now. So y is nothing but, you can put in any equation, right? Let me just add a slide over here. I'm getting x value as 3. For y, I'll use the equation. This one I can use this one. 3x plus 5y is minus 6. 3x plus 5y is minus 6. I want to find out y value. So minus 6 minus 3x. Minus 6 into minus 3 times of 3. Minus 6 minus 9 is 5y. So 5y is minus 15. Y is minus 3. X value is 3. Y value is minus 3. X is 3 and y is minus 3. Please have a look. Calculation is there. Nothing else. I hope this is clear. Done. One more time. Question number 10. Find real theta such that this is purely real. So you have to find the value of theta such that this is purely real. Okay. To understand that, I have to rationalize this. Basically, I have to remove the complex part from the denominator. So right here 3 minus 2i sine theta. Over here 1 minus 2i sine theta. Remove this. I have to use the complex conjugate from here. 1 plus into 1 plus, excuse me, 2i sine theta and 1 plus 2i sine theta. Use the expansion in the numerator. Okay, this will be easy. Denominator is easy. 3 into 1 is 3. 3 into 2 is 6i sine theta. Now, the other one, minus 2, if you multiply, you get minus 2i sine theta. And over here you will have minus 4i square sine square theta. Going to be what? 1 minus 4i square sine square theta. 1 minus 4i square sine square theta. Continue please. You have over here, this value you check, it will become plus 4, right? 3 minus 4 into I square, that's plus 4. I can write here 3 plus 4 sine square theta. That's my real part. For imaginary, I have 6 minus 2. That becomes minus 4 plus 2. 6 minus 2 only, right? So 4 I sine theta. Now let me write this as I4 It's I times of 4 sine theta. This is simple, right? 1 plus 4 sine square theta. Now for this to be purely real, for this to be purely real, what happens? Imaginary part of the number should be 0. For this to be purely real, imaginary part of the number should be 0. And this is my imaginary part. This is the imaginary part. So I mean that 4 sine theta should be equal to 0. This happens when theta is what? N pi. These are learnt in trigonometric equations. So theta equals to n pi, sine theta is 0. Clear? So this is my answer. The answer can be any multiple of pi, pi, 2 pi, anything. It will be like that. Okay. Moving on. Question number 11. X plus iy the whole power 3 goes to u plus iv. And so that u by x, v by y is equal to that condition. Looks difficult? Very simple question. If x plus iy the whole cube is u plus iv, then so that u upon x plus v upon y is this. Looks difficult? Very easy question. This is the whole thing over here. Just do the clear expansion. You'll have x cube plus iy the whole cube, and then we're gonna go what? Plus 3 into x into iy into x plus iy. Do the expansion over here. X cube, we have minus I y cube. How come, sir? Because I cube is minus I. So minus I y cube. Over here we'll have plus, take this out, 3x square y with the I over here as well. Correct, na? 3x square y with the I over here. And this will be what? 3xy square with I square. Right? And twice I square. Alright. We get here x cube. Let's write this with the real part. So x cube minus 3x y square. The imaginary part together. Right here. I is outside. 3x square y minus y cube. Okay. Let's do something is common. So let's just simplify that. Yeah. We'll have over here x is common, right? So we'll have x minus 3x y square. 3x y is 3y square, sorry. X common, right? So I've taken x common, right? So x square minus 3y square. X square minus 3y square. And over here I can take y common. So have I y will have 3x square minus y square. Now compare this with what they've given, u plus iv. Compare this with u plus I. You're getting the value of u as, take this out, this is the whole thing. So u is going to be x times of x square minus 3y square. Okay. So u by x becomes what? Take this out. Simply x square minus 3y square. What about v, sir? Compare the v now. Compare the v part from here. You'll get y times of 3x square minus y square. Okay. Take this. You'll have u by y as 3x square minus y square. Correct, not taking the y over here. Here also same thing, taking the x over here. Clear? I want to add these u by x and v by y. I want to find what? U by x and v by y. U by x and v by y. Add them. What will you get if you add them? 3x square plus x square. That's 4x square. Minus y square minus 3y square. So minus 4y square. Take 4 common. Check carefully. Check here. Okay. And nothing is there, just simple expansion. If you do that right, rest everything is steps. You can do that. Calculation is there, nothing else. Express this in the form of a plus ib. Very difficult question. Very easy. You'll see. What is the numerator? It is, sir, a plus ib and a minus ib. So basically, sir, what is that going to be? T square minus, you'll have simply plus 5. Correct, na? Right? T square, because a plus ib and a minus ib will become a square plus b square, right? In this case, so 3 square plus b square of root of 5 will become, if you want I can write it over here, root 5 the square, and over here if you expand you'll get root 3 plus I root 2 minus root 3 plus I root 2. Root 3 and root 3 is cancelled. This is nothing but 9 plus 5, that's 14. Over here we have I root 2, and again we have, take this out, root 3 and root 3 is cancelled, right? I root 2 and I root 2. So plus I root 2, that becomes 14 by 2 I root 2. So 7. I get what? 7 by I root 2, right? So let's multiply this with I over here. I get what? 7I upon, what is this going to be? I square, right? I square, and we have root 2. 7I upon I square root 2. This becomes what? Check. 7I, so minus 7I upon root 2. My number is coming as minus 7I upon root 2. Rationalize it one more time. Minus 7 root 2 I upon 2. This is the number. So if you write in terms of a plus ib, you will have 0 minus 7 root 2 upon root 2. So a is 0, b is 7 root 2 upon. Please cross check for calculation. There might be some mistake, but I hope it is right. Anything is there, and if you're getting a different answer, let me know that in the comment section. Okay. Question number 13. It says z1 is 2 minus I, z2 is 1 plus I. Find the value of z1 plus z2 plus 1 divided by z1 minus z2 plus 1. Find that individually. What is this value? z1 plus z2 plus 1. z1 is, sir, 2 minus I plus 1 plus I. So I and I cancel. 2 plus 1 is 3. Right? Let's find then z1 minus z2 plus 1. We'll have, sir, 2 minus I minus 1 plus I, and we have plus 1 also. I did not write plus 1, no? 2 minus I plus 1 plus I. You have to write 1 plus 1 also over here. Sorry, that's 4 actually. My bad. That's 4 now. You have to write plus 1 also. So over here what do we have? 2 minus I minus 1 minus I and plus 1. So this minus 1 plus 1 cancels. I have what? 2 minus I left. What I have? Excuse me. Right? No, something is missing. Is something missing? z1 minus z2 is there. z1 minus z2 plus 1 is there. So we have 2 minus I and 1 plus I difference. So minus 1 minus I, minus 1 and 1 cancels. Minus I and this is left. Okay, correct. Let's continue now. We have the value as 4 upon 2 minus I. 4 upon 2 minus I. Rationalize it. We'll have 2 plus I upon 2 plus I. We're going to get what? We'll have 4 times of 2 plus I upon 2 square plus 1. That becomes 8 plus 4I, and upon what we have 3. So 8 by 3I and 4 by 3I. Please cross check, okay? The answers please cross check. Alright, z1 is 2 minus I, z2 is 1 plus I, right? z2 is 1 plus I. Yeah. Let me just cross check. z1 is 2 minus I. So if you add them, 2 plus 1 is 3, that's cancelled. 3 plus 1 is 4, that's correct. And difference if I take, so we have minus 2I, 1 minus 2I plus 1, 2 minus 2I. Sorry, 2I, sorry. This is correct now. This is 2I, my bad. 2I, this will be what? Sorry, this part is correct, sir. Corrected. If this is coming as 2 minus 2i, so we'll have the answer as 4 upon 2 minus, I can take this common, 2 and 2 cancels. So I have here 2 upon 1 minus I. So multiply this, 1 plus I upon 1 plus I. So we get 2 times of 1 plus I upon, this will be what? 1 plus 1, right? So I get the answer as cancelled, right? 2 times of 1 plus I upon, yeah, will be cancelled again. You have the answer as 1 plus I. I hope this is clear, right? I can explain again. When you take difference, you'll have 2 minus 1 is 1. Minus I and minus I will be again minus 2i. But if you add 1, it will become 2 minus 2i, right? 2 minus 2i. And that if you take 2 common over here, it becomes 2 times of 1 minus I. Rationalize it with 1 plus I. You get 2 times of 1 plus I, and this 2 and 2 is cancelled. So 1 plus I and this 1 plus I. 2 times of 1 plus I, this will be simply 1 plus I square. Yeah, that becomes 1 minus I square, that becomes 1 plus 1, which is 2. So answer is 1 plus I. Please check. This is clear? 13th one is okay. So that is all in this particular class, where I have discussed your FA-1 for first PUC math chapters. I have discussed what? The number 1 was sets, number 2 was relations and functions, number 3 was trigonometric functions, and number 4 was complex numbers. You will find notes also in the AIO page. So please check on that. The link is given in the description. So check for free ACE batch. Okay, the link is there. Click on that. Check it out. And I've given you theories also. I've given you concept formulas also in the session itself, the PDF, the PDF itself. Please check it out. Anything else you want from me? Leave that in the comment section. That's all in this particular class. All the best for your FA, and I'll see you in the next session. Till then, take care. Bye bye.